होगा सीट 30. Director something.
Good morning, Dr. Sivasamy. Good morning, Dr. Sivasamy ji.
I think he is not listening.
You have to unmute. Dr. Sivasamy, you have to unmute.
Good morning to all.
Good morning, Dr. Sivasamy.
Yes, sir. Good morning, sir.
Program की copy तो inauguration.
He is not listening.
मेरा notebook Hello. Priya, we are Ravi Kumar. ABI 25@gmail.com. Yeah, I'm sending you one link, please. You can you have to register with your name. Okay. Yes, that's awesome.
link के लिए आता ही रहेगा प्लीज
Good morning, sir. Good morning, everyone.
Good morning. Good morning.
Good morning.
Morning,
Good
sir.
morning.
इमीडिएटली मेरे का पीके से को भी चाहता है ना, इसमें क्लिक कर दूंगा। झांसी का
சொல்லுங்க பர்லின். அது அந்த ஒரு பிரிண்ட் அவுட் எடுத்து கையில வச்சுக்கோங்க. ப்ரோக்ராம் கையில வச்சுக்கோங்க. யாருக்காவது லிங்க் கிடைக்கல இல்ல பிரசன்ட் பண்ண முடியலன்னா அவங்க கிட்ட கோஆர்டினேட் பண்ணணும். ஒண்ணு. இந்த ராஜு ஐபிஎஸ் அவரோட நம்பர், ராபினோட நம்பர் இருக்கு உங்ககிட்ட? இல்ல. இந்த பார்த்துட்டு ஒரே நிமிஷம். Yeah, I sent it. I sent it. Separately I sent it. Some free or some mail. Along with DDG, I sent it. DDG responded, but DDG responded. No, I sent it. On the same day I sent it. Okay. Yeah, we can start. Yeah, DDG. DDG. Yeah. This you ask the director that can you start. That's one of the years to do something. You start, you ask him, otherwise you will start. Yes.
ಇಲ್ಲಿ ಬಂತು ನೋಡಲ್ಲಿ ಬಂತು. ನಲ್ಲತಂಬಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್. ನಾವು ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಹೋಗ್ಬೇಕಲ್ಲ.
Good morning.
ನಲ್ಲತಂಬಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಐ ಆಮ್ ಲಾಗಿನ್.
Thank you, sir. Good morning, sir.
ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಕ್ಲಿಯರ್ ವಾಯ್ಸ್ ಕ್ಲಿಯರ್ ಆಯ್ತು. ನಮ್ಮ ಕೆಲಸ ಆರಾಮ್ ಕೂರಿ ಸರ್. ನಮ್ಮ ಶುರು ಆಯ್ತು ಇವಾಗ. ಏನ ನಾವಿಲ್ಲಿ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ Devappa, good morning.
Very good morning, sir.
How are you? Fine.
Fine.
Yeah.
So, my dear respected members, just I want to make one small announcement here. So, our IPS President Dr. P.K. Chakraborty sir and DDC T.R. Sharma sir will be joining at 10 o'clock. So, we'll start at 10 o'clock. This program will be started at 10 o'clock.
Dr. Robin.
Yes.
This is being the first virtual IPS-South Zone Symposium.
Right. This is
Why
the
don't
beginning.
you ask all the IPS members, irrespective of the zone, to join for this inaugural session at least. And once the inaugural session is over, then the technical session, whoever registered can remain.
Now, it was sent to all the zonal presidential councillors to make publicity in their zones.
But now you have got time, around 20 minutes you have, if it is sent to all the members, to whoever free, they can join for the inaugural session. So that would be better, because DDG and Director IRA and all, and many vice chancellors are here, and Rashmi madam is here. So many are here too. So it would be nice that everyone joins in this inaugural session.
Yes. Okay.
You just send to all the people from your email, just this link. If they just click it, they can join like that instead of, yeah.
सबको ज्वाइन के लिए मोबाइल के लिए ओपन कर देना है।
Niranjan sir, good morning.
मेल सेंड करके फोन भी करना।
Suresh, good morning.
Good morning, Dev. How are you?
Yeah, fine. So
Yeah.
you got up early.
No, it is 11, 7, 10.
7 o'clock. Okay. Good.
Yeah.
Good morning, Dr. Suresh.
Good morning. How are you?
Fine.
It is nice to see the activities of IPS. Yes.
Yeah.
सारे मेंबर्स को दिखा दो।
सारे मेंबर्स
को जाना चाहिए। सबको जाना चाहिए।
नहीं पाएगा।
को भेजो।
है किसी का काम है।
दो
बस साउंड
हमारे ग्राफ में रखो।
साउंड को तो गया है। सेंट्रल जन कर दो। अगर निकाल सकते हैं। एक कंसोल एक जन।
एक सेंटर है ना। इसको भेज दो सर सारे मेंबर्स को। दिल्ली जोन को भेजो।
जितना होगा दिल्ली नॉर्थ WhatsApp, email ना ये सब करने के बाद फिर अर्जेंसी तो कॉल करना बेस्ट है।
Oh, Veena and Mitra and same time.
Robin, good morning.
Good morning, sir. Welcome.
How are you?
Yeah, fine.
You are looking fine in Delhi.
Yeah, we are always fine.
Raju also.
Sir, good morning, sir.
Good morning, Raju.
Good morning, Dr. Niranjana.
Hello,
Hello, good morning.
madam.
Yes,
आप दिखाई नहीं दे हाँ मैडम गुड मॉर्निंग अभी
good morning.
अभी
अब
दिखाई नहीं
दिखाई
दे
नहीं
रहा है हाउ आर यू मैडम गुड
I'm
मॉर्निंग
very fine.
गुड
You
मॉर्निंग
were telling in Delhi everybody is fine, so I showed I'm also fine. Till now.
Delhi everybody is fine
Yeah. They should be fine.
yeah
Hello, ma'am. Rashmi, ma'am. Good morning.
Yes, good morning, Uma.
How are you, ma'am?
I'm fine. Very fine.
Ma'am.
Very nice.
Okay.
Today Nalathambi called also.
Okay, ma'am. Okay.
Yeah.
Uh,
So we will, I think, and it looks like it will start at 10 o'clock.
10 o'clock. Yeah, yes, ma'am.
Doing some work.
Yeah.
Sir, good morning. Robin Gogoi sir and Raju.
Good morning, sir.
Good morning, sir.
Niranjana sir. Niranjana sir. Thanks. யாருக்கெல்ல சொல்லும் வைஸ் சான்சலர் ஆல் தி வைஸ் சான்சலர் யாரெல்லாம் வைஸ் சான்சலர்
நிரஞ்சனா நாயகி மற்றவங்க ஆல் வைஸ் சான்சலர் வரலன்னா அந்த நாட்டோட ஜாயின் பண்ணுங்க. then it is then it's fine. That's the classical way of doing it.
Yes.
What media we are going to do, we do it. So it has to be linked to even maybe we have to do, or even go to yeah. You can go for you account, but then the customized CCAP is used here. So that all the grading organisms come out. So a lot of so Windows is clear now, and it should be targeted towards that. There is some at least we need a decent population of around 200, 300 box. January, February, the collection. March, yeah. So that might bring another question. Good one. So this microbiome, whatever you preserved it, you will handle it in a different way. Think of another couple of more media. Okay, what I found is manicular based media, the diversity is more. I recorded long back. See, diverse kind of organisms, different shapes, size, color. It is something which most preferred. Anyway, think, yeah, this 80. Now DNA isolation, you nothing with the box PCR, eliminate duplicates, send it for sequence. The flow make it complete. Okay. You send it for sequence, send everything together.
Good morning, Akshay. Dr. Sharma has joined.
Yes.
Very good morning. Good morning to all. Namaskar.
Good morning, sir.
Morning.
Good morning, sir.
Very good morning.
PK Security sir has also joined.
Volume குறைச்சிருங்க. Complete.
Sir.
போன கூட
ನಿಮ್ಮ ಅಟೆಂಡರ್ ಓಹೋ ನಿಮ್ಮ ಅಟೆಂಡರ್ ನನ್ನ ಬ್ಯಾಗ್ ಇದೆ, ನನ್ನ ಕಾರ್ನ ಒಂಚೂರು ತರಿಸ್ಬಿಟ್ಟು.
Dr. Gogoi, can you start now? Dr. Chakraborty is also joined.
Yes. Dr. Nalathambi.
Yes, sir. So, with the permission of the dignitaries, let us start the program, sir. So, I think all the members have been comfortably registered. And now the next program is the welcome address and about the zonal symposium. First, I welcome the Honorable Deputy Director General Crop Science, ICAR, New Delhi, and the President of IPS, Dr. P.K. Chakraborty, and our Director, Dr. A.K. Singh, Vice Chancellor and Director of IRI, New Delhi, and Dr. Rasmi Agarwal, the Head of the Division, IRI, New Delhi, Division of Plant Pathology, and all the Vice Chancellors of different universities, Dr. Niranjana, Dr. Naik, and all the delegates from different parts of the country. Sir, it is a great privilege for us to welcome you all for this virtual zonal symposium. And in fact, we didn't expect that this much response we'll get. But we have about more than 200 registrations from, at least from the South Zone. We didn't disturb the other zones because subsequently they'll be also conduct the same meeting. So within South Zone, we have more than 200 registrations. And we have called 4 sessions, and we have the 3 keynote speakers, and one our own the South Zone member. Shortly will be joining from North America, Dr. Jairaj, and we have another keynote speaker, Dr. K. Lada from the Vice President of the Stains Company in Coimbatore, and Dr. Naik from the Vice Chancellor, University of Agriculture and Horticultural Science. And apart from that, we have eminent pathologists for the lead paper presentations. And in each session, for all the 4 sessions, we have 3 lead paper presentations from different areas. And we have simultaneously, after that, we have 5 oral presentations from all the sessions. Of course, it's a mandatory to have the Professor M.J. Narasimhan Award contest. That will be in the second and next day. And all the meetings, we have the concurrent sessions for the posters also, because we have overwhelming response from the participants. And in fact, we find difficulties to accommodate within this 1 or 2 hours, but we made a concurrent session. I think I am very grateful to our headquarter office. They were very kind enough to facilitate us, and because of them, we are comfortably conduct this meeting. So with this few information about this Zonal National Virtual Symposium, I once again welcome you all, the dignitaries, particularly our authorities who are very kind enough to grace this occasion. Really, I'm very happy that sitting in a very remote place like Wellington and Nilgiris, and we never thought that we'll be able to conduct this type of meeting. And with all the support from my colleague, our head of the station, Dr. Swasamy, all my scientists, they cooperated nicely. And because of them, all the pathologists from the South Zone, and we could make this function live. And once again, welcome you, sir. Thank you. Now, may I request Dr. Robin Gogoi about this IPS activity to highlight the IPS activity. Next.
Yes. Beginning very last slide. So, the slides are visible?
Yes, visible. Dr. Robin, you can go ahead.
Yes, sir. Yes, you can proceed.
Okay. So, good morning, everybody. So, respected Dr. T.R. Sharma, DDG, Crop Science.
Good morning.
Dr. P.K. Chakraborty, President, Indian Phytopathology Society, and Dr. A.K. Singh, Director, IRI, Dr. Rashmi Agarwal, the Head Division of Plant Pathology and Acting Dean of IRI, and all the Vice Chancellors, and all the delegates and viewers. I, on behalf of the South Zone Indian Phytopathology Society, welcome all of you. So let me brief about the society for which we are assembling today. This is Indian Phytopathological Society. Next. Let's move here. This is Indian Phytopathological Society, as all of you know. So it was established in the year 1947 by Balachandra Bhavani Shankar Munkur. He is the founder, man of this society. And after this 2 years, the society was registered. Next. So objective of the society also, it is all available in the website. I am not going to mention here. So next. So we are proud that this society is the third largest society among the plant pathologists in the world, having more than 2,500 members. Next. Next. And as we know that the society has got 8 zones in the country. So that out of 8 zones, we are assembling today the South Zone meet. Next, please. So we are having so many activities. So this is the mirror of our society, Indian Phytopathology. This is a journal. So this journal accommodating so many research findings done by our Indian plant pathologists as well as from the world. And the journal has been published under this publication is for the last 2 years. Next, please. And the last 2 years, we started publishing this newsletter in the name of Indian Phytopathology. So our motto of this newsletter publication is to disseminate the information in the first place. Next, please. So time to time, so we used to publish some of the books based on the selected subjects. Next. And the society is holding this many symposia and also conferences. The first international meeting was held on January 2nd in 1948. So far, 7 international conferences have been organized and 72 national conferences. Next, please. And the society instituted 17 awards. In the last year, 3 awards added. And apart from these awards, for the students also 2 coveted awards are there. One is M.J. Narasimhan Academic Merit Award, and second one is IPS Travel Grant. That is for the PhD students, and M.J. Narasimhan Award, it is for combined this MSc and PhD students. And proceed. So with to keep with the pace with the recent development of the, and also timing, so the society recently renovated the office. So with all the recent updations, we are trying to add. Next, please. And the office was inaugurated by our Honorable President Dr. P.K. Chakraborty in presence of Dr. Rasmi Agrawal, and also in presence of our former Secretary Dr. S. Chitari sir. Next, please. And we are trying to bring our society in the online mode, fully online mode. Here, different the aspects to be covered under online mode, like online payment, creation of subdomain website, then online abstract submission, then online election process, online access of the journals, newsletters, then online award applications, then online archives, and also online photo, video galleries, etc. And also recently we have added this account in Paytm, through which one can deposit their membership fee, and also they can join, they can submit or deposit the ration fee of different conferences and symposia. And from this year, we are going to hold our Indian Pathological Society election in online mode. Of course, this is the first time we are going to organize. That's why offline mode will also be there for those members who don't have, or who has not given, or whose this email detail and mobile detail we don't have. And for others, out of 2,500 members, about 1,500 members we are having all detail, so they will participate purely or through online mode, and rest around 600 or 700 people will be participating in this election in offline mode. So this already we have announced this nomination submission. Already we hold mock election among our this executive members to eliminate some of the defects or points which is to be updated in the online mode of election. Next. So similarly, already I have told that online in online mode one can apply for nomination of award as well as application of award, and this will be announced for this year from 15th of January. So this is the form you can see from our Indian Pathological Society website. And this is the last slide. As we have, I have mentioned that we have got 8 zones, and we are very happy that Southern Zone came forward to start the zonal symposium. Today we are assembling, and Dr. Nalatambi and in association with this councillor, zonal councillor Uma Maheshwari, they are able to hold this meeting for 2 days. I wish both of them best wishes to make this program a successful one, and as well as I will request all the other 7 zones, this zonal president and zonal councillors to get ready. So here the entire list of this zonal symposia series. So the last symposia will be organized by the Northern Zone in the last week of January 2021. Next. So this is about briefly this Indian Pathological Society. So I thank all of you, and so I wish the program will be a grand success one. So I welcome all of you once again. Thank you.
Thank you, sir. Good morning to all. Now, I request Dr. P.K. Chakravarti, President IPS, to give a series of, to talk about the series of IPS virtual symposium. Sir, please, sir. Hello. Hello.
He's online.
Hello.
He's not. No.
He's there.
Hello.
Yes, I'm there.
Yes.
Good morning, everybody. And it's nice to see you all. And we have a panel of very respected, our eminent guests of today, and Dr. A.K. Singh, Ashok Kumar Singh, Dr. T.R. Sharma, DDG Crop Science, Dr. Ashok Singh, who is the Director and Vice Chancellor of IRI, Dr. Rashmi, and all the eminence, Dr. Siddhapura, Dr. Sridhar Ranganath, and many of our esteemed scientists are there. I'll not take names of all of them lest I miss anybody. And you have created this society, in fact, and with your help only we are able to make so many advances. So I welcome you all, and I have not made any formal presentation, and as it was kind of, we have other things going on in ASRB, and this pandemic has really put us to make us learn so many things, because we are now doing multitasking here. Had it been a normal time, we would have gone for a very formal way of presentation and very formal way of all these things. But now simultaneously I have to do other jobs in ASRB also today, which is very important. Dr. Nayak, I'm just good morning to you all, because I'm not able to see all of you in one platform, so in one side of the screen. So that's why I'm not able to name all of you. And I just joined. I'm sorry, because there was some kind of miscommunication, and I thought it is going to start at 10 o'clock. And so just now I came to know before coming. So just to start with, IPS has a glorious past of 73 years, and many of you know, you are a part of this, and it shares its birth here with the birth of independence of this country, the year of independence, and is the first of the third largest global societies in the country so far. And plant pathology, when it started during 1947, this society took birth by need, by the history of plant pathology, and the situations had created those kind of things, so that a group of very eminent scientists at that time of plant pathology, they initiated this. They wanted to introduce this society and started this society because all of you will be knowing the Bengal famine in 1942, because of which the rice was wiped up and almost 40 lakh people were affected. And that was the beginning. And before that, of course, history was already created with Irish famine and all those things. So this important area was realized as a very important area for food security. At that time, we were just having a mere subsistence from because we were just depending upon the import, and whatever food was grown, it was subjected to wrath of various kind of plant pathogenic diseases. Now, when we see, we have come from 50 million tons to maybe 7 to 8 to 9 times higher production of food grains, and we are become now self-sufficient in crop production. We have it has become brought in different dimensions of problems and different dimensions of challenges as well as opportunities. So what I would like to say, that 1 in 9 people in the world now suffers from hunger now because of the growing population. And more than 2 billion, although to say we are self-secure today, but we have to sustain this productivity and production. So for that, this biotic stasis comes at the first and foremost. I believe many of you stalwarts, Dr. T.R. Sharma, Dr. A.K. Singh, you have been very much involved in having food, means making the country food secure. But having produced very good varieties, they just in due course of time they succumb to many of the diseases. So that this process has become a dynamic process, and we need to be continuously striving for it. I was telling, 1 in 9 people in the world, this is the latest data in world, suffers from hunger, and more than 2 billion experience moderate to severe food insecurity. By 2050, food demand will rise by 60 to 120% as the world population goes beyond 9 billion. And this is the data which has been published in PNAS as well as FAO bulletins. FAO and CABI recently reported that whatever food is produced in the globe, 20 to 40% of the food is lost to pests and diseases. In Indian context, it is estimated that the crop losses, I myself tried to do, but so far no systematic work has gone for estimation of crop losses. Recently, there has been demand under Pradhan Mantri Fasal Bima Yojana and all, where crop cutting experiments are being done, and farmers are often have to be given, they are demanding some compensation of losses. So we do not have in India a real estimate of losses, but the overall guesstimate shows that 20 to 30% of losses occur every year. At this rate, 65 to 70 million tons of food grains we are losing, and 70 to 75% of horticulture and vegetable crops are lost every year, causing a monetary loss of more than 2,25,000 crores. So this thing has become kind of incipient kind of losses which we are not able to gauze. We are able to gauze the losses because of the pandemic, where within the first 3 months, $9 billion worth of losses had occurred within 3 months. But then in these cases, when the plants die, we do not really make a notice of it. But this is the amount of loss. If it can be curtailed, this loss, if it can be curtailed, we can feed 25 to 30 crore people till 2050, which is our the population which will be there, without any increase in productivity. Even if we do not have any productivity enhancement, even if we can save this amount of loss, we will be able to feed our population. But it is often easier said than done. We need to do. Developing countries like Australia and all, they do not, they cannot tolerate. They say that they boast also of telling that they don't lose more than 5% of their produce. But then we need to have, we have a rampant loss, and we need to reduce that gap of losses which are there. In 2019, European Parliament, they are most concerned about the use of pesticides. They had in their parliament a special committee which was set up to see whether the pesticides, because they are the most wary countries in the world to make use of pesticides. And the committee had to give a report telling that if European Union loses or stops use of chemical pesticides, including biopesticides, 50 to 60% of their crops will be lost. So this is the important in their country, and definitely it is without going, it is there in our country as well. Recently, incidences of endemic diseases, emerging diseases, diseases of unknown etiology like mango wilt and all, and mixed infections like you all have heard, Tiranga disease of tomato. Mango malformation has been found to be having different etiology now. There are recently phytoplasmas have been found. Non-conventional pathogens such as phytoplasma, citrus greening, and they are becoming more rampant, and transboundary diseases have become most prominent. This may be due to climate change, crop intensification, then changing cropping pattern, increasing globalization, and trade with other countries. So all these areas were never existing earlier when we got the independence, but now these are the newer challenges, and which also gives us opportunities to work for it and to mitigate the problem. Plant protection in India is although has gone through many transitional and scientific approaches of pest management. The holistic plant health management through integrated and good agricultural practices involving host plant resistance, cultural, biological, behavioral, mechanistic methods, besides the curative use of pesticides supported by legal framework, is the order of the present day. Whatever may be happen, we are giving sometime lip services for the biological control and other biostimulant based management and other strategic and cultural methods, but ultimately overwhelming is the pesticide use, and that is the way we are saving. We are although world's lowest user of pesticides with 55,000 tons of pesticide. Present day plant health management, it demands a coordinated and collaborative approach in the era of information and communication technology, wherein the technology intensive and subjective plant health management can be implemented through area-wide pest surveillance, digital pest management advisories issued to growers at a time of need. So this is the one where we have to further go. We have to advances in the plant pathology sciences, advances in ICT based approaches, advances in omic approaches, omics and various other approaches are there. So we need to diagnostics. Diagnostics have become very rampant, but they are seldom used. Nobody uses it for detecting the weaker link of the pathogen which are surviving, overwintering, or over summering in the sources, so that we can develop a link and then ultimately hit the pathogen at a stage and make the plant protection strategies more effective. Such an enveloping of technology and information driven plant health management has been limited in our country, that has with an arable land of 159.7 million hectares with a crop intensity of 141.6%, which is highest in the world. Investing in plant health research is necessary to withstand plant diseases, reduce food insecurity, feed and the growing population, and make our planet more sustainable. Thus, protection of crop is paramount to preventing and preserving food security and sustaining farmers' income and economy of the country. Year 2020 has been very befittingly being marked as the International Year of Plant Health. An Indian Phytopathological Society is bound to fulfill its obligations. We are already going ahead. Even ICR has initiated a challenge, under the leadership of our DDG Saab, as well as our Vice Chancellor Dr. A.K. Singh, and many other areas. All the institutes are taking up this challenge as a year of plant health, and this is bound to fulfill its obligations toward the society and farmers in upholding their livelihood and meeting the UN Sustainable Development Goal. One of the biggest limitations of effective management of losses is the yawning gap. This, Dr. Singh, I think we need to see. It's a very big issue. There's a yawning gap between the theory and practice of plant protection in India, which is happening. I'm not telling you only. I'm telling the entire fraternity who is sitting here, and authorities as well. As this gap means whatever plant protection we are practicing now, even in IRI, even I was doing in my previous institute, they are not amenable to see light of the day. Whatever plant protection, chemical management and other strategies we are doing, it is not ready to go because it is not as per the government rules. Testing the pesticides and doing and using the biopesticides, just simply, even though we are, if it is effective in early managing but they should be as per the government directions for approval and registration and label claim and so far and so forth. So many things are there. Secondly, there is a lack of a platform of interface between the four major stakeholders of agriculture: academia, which is a knowledge base, industry, policymakers, and farmers. This I have been telling through my addresses in my through my newsletters or my messages through newsletters. We seriously do not see eye to eye with each other. That's why we have recently seen many ban of pesticides, one-sided, many government rules, so certain very positive rules like robust and drone application first time in plant protection, but none of them they meet the requirement. Then for pesticide use, if you have to use certain pest controller operator, without which you cannot use certain pesticides, then who
Please unmute. You got muted.
Yeah, sorry. So those gaps needs to be filled, and our scientists in IRC, whenever plan any plant protection related program, they must call somebody who is from the policymaker side, somebody who is from industry side, and that way PPP mode of thing will be coming. You know, you are a pioneer in developing bringing clear field technology in the country now, but this technology was first brought by a private company, BASF, and now you have really done a wonderful work where you have made a rice which is insensitive to this imidazoline group of herbicide. This is a path-making research. So industry, policymakers, they need to come. Similarly, it was the first GM technology which came to India again for pest management only. That was also brought from by the industry only. And HTBT cotton, which has been banned, but I say this is a purely farcical thing. It should never be banned. This is a very good technology, and this is the lack of faith of the industry on us, on the public sector, that they have withdrawn it by themselves. It is not banned, but they have withdrawn, thinking that they will not get a due share and due whatever share some kind of, they will not be meeting with the proper treatment with the industry, because we had one-sided, we have slashed the trade value of the previous GM crop. So they were afraid that the GM or trade value for this technology which they brought by spending millions of rupees and crores of rupees, that Indian government may not support that, and they may at their one-sidedly they may deprive them of the benefits. So we need to bring. So in IRC, my request would be to definitely invite policymakers, because while you are doing, your technology should be field ready, and it should be conforming with the government's rule, and it should be a need for the industry and farmers, of course. That is the fourth stakeholder. Advanced academic institutions are mostly working on advanced biology of host and pest. Without, now I'm telling how four stakeholders are doing something which is very important, but they are not being translated. Advanced and academic institutions are mostly working on advanced biology of host and pest without translating the knowledge for the timely detection and management and of plant diseases. So it should be put a pest, but since it's a disease-based society, so I am telling timely detection of pest, which disease causes about 20% of losses. Industry now, they work independently, and there is rarely much effort in forging a PPP mode to engage a greater coordination. Policymakers and bureaucrats often enforce legislation based on their own perception. So there they don't call academia, they don't call industry, and just with their own perception and understanding without engaging with these stakeholders. Farmers who are at the receiving end are often illiterate, suffers from lack of awareness about the technology and regulations, and are guided by the unscrupulous dealers, resulting in practicing off-label and unscientific use of crop protection methods and chemicals, defeating the basic tenet of GAP, good agriculture practice, for effective pest management and protecting crop losses. So this is the drawback for the industry. Thus, concerted efforts and coordination of all stakeholders are required to make crop protection successful and agriculture a profitable, sustainable venture for farmers. In this area, crop protection scientists and professional societies like IPS has a very big role and responsibility to play. Thus, some of the areas need scientific discussion and practical solutions in the International Year of Plant Health. And further, some of them I have highlighted, and some of them our society has already advanced, and ICR has really done, also started working on that line. This I have realized as a bottleneck or gap which I felt while working as a scientist, while working in a research management position, while working closely in association with the policy makers. First and foremost, nowadays also Pradhan Mantri Fasal Bima Yojana, which has come, the SOP for which was designed last month, means in the month of October, and in the month of October, there still we have not included the crop cutting experiment which is there for making Fasal Bima. There is no actual incorporation of elements of losses due to pest. There is no method by which losses have been there. Losses in general is explained, but not the due to pest and disease. So we are not really knowing what are the actual losses. So computing actual losses due to individual diseases in individual crops. So this needs to be worked out. So far, what we say, we generally say 20 to 30%, 20 to 40%, or something. When I attempted to see, and I approached individual institutes and directors of all institutes, I collected data. I was surprised and aghast to see that if the losses were added, it used to go to 100% even. When I asked the director of cotton, he said pink bollworm 10 to 15% losses, complex bollworm, some other things, gray mildew this much, bacterial blight something. If you add all of them, and this adds to. So we need to have a good estimator of losses. Role of climate change in induced pest and disease. We all say that climate changes are making us vulnerable, but is it so? Because billions and millions of sources are being exploited in the name of climate change. But right from the time we were born and we started knowing and reading and studying plant pathology, we have been seeing one or the other pathogens coming all the time. So is it the climate always changing? Today, why we are suddenly talking about climate change? So we need to have, in NICRA, there are certain experiments which are going in isolation. So we need to see those. Mapping threats of invasive pests. For last 5 years when I was ADG and during this year also, I have known that there are constantly every year certain transboundary diseases, some invasive diseases and pests are coming. So can we make do a mapping of these invasive pests which are present in the region around us? So some of you also, some of our researchers needs to work on that. And this may have happened because of increased globalization, because India is the country where our laws are made in such a way where when fall armyworm came in 2018, I knew in July when it came, it was reported to us. We had a policy paralysis. We didn't know whether we have to tell that. Similarly, when wheat blast was there, still today we say it is wheat blast like disease. We are always afraid that our trade should not be affected. So we need to pitch in with the policy makers to say, sometimes we become a ridiculous talk when FAO knows, when other people knows, India does not declare that the pest has come or insect or disease has come. So we need to develop a policy, whether we or how long we should keep on hiding that, because ultimately in that case, our strategy changes. Other part of the world who have already experienced such kind of, to tackle such kind of thing, they do not come forward. And once we do not declare that we have a disease or a pest which has come to India which was not present, so nobody will take a claim on that. Neither we are able to report what we are doing in that line. So this is another policy. There are certain policy issues have also come in way. Pest risk analysis and gearing to quarantine the economically important and invasive pests. So this is one course which needs to be done, initiated. A course on biosecurity needs to be initiated. I hope plant pathology department in IRI at least have a course on biosafety and biosecurity. People, when they come for interview, they do not differ. They do not know how to differentiate biosafety from biosecurity. But recently, one of the authorities, one of the brigadiers from Galwan Valley was deputed by Government of India to work upon a national biosecurity plan encompassing not only human, because this is after the pandemic was broken, outbreak was there. So he, fortunately, I had a chance and he came to me and we had a long discussion for about 1.5 hours, and he is going to create a platform where agroterrorism will be discussed with respect to, because they have already experienced that in the border area between India, Pakistan, India, China. They have seen certain organisms, microbes, which are never existing in the country. So who will help? This academia has to come forward, and the coursework should address some of those issues of agroterrorism, which might be there. Like I say, weed blast could be an example of an attempt for agroterrorism in our country. Otherwise, suddenly, after 20 years of its report in USA and in Bolivia, suddenly it appeared in our border with in Bangladesh area, adjacent to our India, and where wheat was grown, and ultimately it was recorded that when we claimed it as a wheat blast-like disease. So, but for the first time, I felt the government of India took a very right step. Before that, of course, you have very well tackled the entry of UG99. Such kind of awareness has to come, and some strategies have to develop. Redefining the list of quarantine pests of significance in Pesticide Management Bill 2020, which is there in the Parliament. We need to redefine. There are schedules 7, 8, and 9, which shows what are the pathogen, what are the pests, and what are the weeds which are of quarantine significance. So that was made in 2003. Now, 17 years from now, many of the pathogens have already established in the country. We are the ones we have to go. DSC does not know anything about it. We only need to emphasize upon that need, and we need to say that the quarantine or pest management or plant quarantine order needs to be changed, and the revised schedules have to be made for quarantine pests and diseases. So the older diseases have to be removed, newer diseases and threats which are still not in the country has to be put there. How prepared are we to fight the threats of agroterrorism? As I had already said, so this we need to see, because suddenly a pest comes. Australia says had it been in their country, they would have burned that area. When fall armyworm came, it came in Polachi in a small village, and it was restricted. But we took about 3 months, 4 months time to tell that fall armyworm has come. Within that time, the pest spread to about 9 different states. So these kind of things we need to see, and we are not yet ready to fight the agroterrorism in case. So we need to see how we are geared towards that. Use of drones and mechanization of small and large farms for smart farming and efficient plant protection. So all these things need to be addressed. Then use robust protection strategies of high value, low volume crop species. You will be again surprised and aghast to know that we are exporting, we are the world's largest exporter of spices, but so far, am I audible? I'm getting a call from Robin.
It is audible, sir.
Yes, sir, audible.
Okay, okay. So what I wanted to say is that this high value, low volume crop like spices, we have $4,000 million US worth of our exports from India. But the other day we were seeing in the board, nobody knew that 88% of large cardamom is exported from India, and there's not even a single pesticide like for its management. No pesticides are registered on any of these spices. Why not? So their industry should come. Their our people should work upon, and we have developed a crop grouping strategy, or we have developed an SOP. Government of India, fortunately, I got the opportunity to be the chair on that committee, and we developed an SOP for crop grouping. India would be the second or third country in the world to adopt crop grouping, by which at the moment we have hardly 15% of the crops are under registered use of pesticides, while 85% of our crops, they receive unregistered use or off-label use of pesticides. So we have to reverse that order. So for that reversing, at least Government of India, it converged, it came and it heard us, and then we made an SOP by which we can go for development of group MRL, and so that 85% of our crops, and at least crops which we export, which earns lots of foreign exchange through that export. At least today, crown gall of coriander, you all know, it was a minor disease of no significance when we used to study. Today, 40 to 50 to 60% of all coriander, which is the major business of some of the villagers in Rajasthan, farmers, that is lost because there is no pesticide registered, and you cannot export a commodity without. So, so this is the amount of losses. So no pesticide is registered. Industry, they do not come forward because they have to pay 50 lakh rupees for registering their every pesticide on each crop. If a pesticide is registered on wheat, they are ready because it's a high volume crop. There they sell about 20 tons, 30 tons of pesticide they earn. But when it comes to dhania or jeera or any spices, they sell a very less amount. But even then, they have to spend 50 lakh rupees for registration of the same pesticide, which is important there, which is useful there. Here also in case of spices, but they need to pay 50 lakh rupees again for registering. So they suck those. So that's why we have made crop grouping based MRL, where we have streamlined and harmonized some of the technology. You have to work. All the EU scientists need to see those rules are already existing, but how many of our researchers are engaged in developing and registering pesticide on or data on biosafety and residue analysis of the following gap. So this needs to be done. Our molecular diagnostics have become a mere cosmetic in Indian protection. I say yes. I have a patent on seed-borne detection of Xanthomonas 18 race 18, but nobody uses it. I have a patent on that, but so far they remain as a PCR method. So far they remain in a format where I am not able to use them. It is of no consequence. Only I will be able to tell I have a microarray chip, I have a Affymetric chip, or I have a certain other kind of modules. But unless they are used to detect before the onset of season, it is going to be no use. Secondly, another point is how safe is the conservation agriculture? We are always harping upon conservation agriculture, but the very tenet of plant protection, may it be plant pathogen or maybe 3/4 of the life of a pathogen or a pest is passed in a soil. In a zero tillage system, I have seen many of the pests which were not of any significance, soil-borne pathogens, they have become important. I am highlighting only those kind of points which are otherwise you are doing wonderful research, but these are the area where you need to work and make our farmers more successful. Mandatory use of available molecular diagnosis in decision making for crop protection invention. Just today, I read in the paper, many of you might have read, that Jamia Millia has developed some pap spit kind of a technology. They say simply put your spit in a tube, boil it, and mix it with the reagent.
Hello?
And after some time, you will be able to detect whether we have corona or not. So that is such kind of technology. A farmer himself can do. Such kind of system needs to come. Mandatory no 5G use of 5G approaches for biotic stress management. We have latest genome editing, which our honorable Dr. A.K. Singh has already used. He has not used genome editing, but he has used the same technology by which genome editing is done otherwise. So this is creating a small SNP kind of changes, whether through mutagenesis or through genome editing. You use those 5G usefully. And some studies you all might be feeling, mainstreaming of
Sir, excuse me, sir. Sir,
yeah.
President, sir, other programs are in schedule, sir. We have to wind up at 11 o'clock.
But just I will be ending because these are the things.
Okay, sir. Okay, sir. Okay,
I'm sorry. I mean, I'm taking some time, but then if I don't tell that, then some of the very areas, because maybe from today onward after 11 o'clock, I will not be able to attend here. So that remains untold. One very burning thing is VOCs, volatile organic compound, and use of electronic noses and acoustics in disease diagnosis and pest management, which other countries have already started doing. Australian and even Chinese have started doing, detecting the pathogen through volatile organic compound detection and electronic noses. DRDO has started developing. We had a WebHub conference where it was discussed. So why not our scientists start doing? And then strengthening research of bioherbicide. A very company within the country has developed 21 patents on mycoherbicides for control of water hyacinth, for control of lantana, for control of pyrethroid. But we in the public sector, we have to catch up. Mainstreaming industry, governments with academies for effective plant protection, managing limitations of biopesticides for mainstreaming in IPM, because we say, but it still remains like that. We have to find the limitations and work them out. Scope of nanotechnology, we do not have any kind of regulations on that. Defining greater role of IPS and other societies for forging greater and defining role. So some of these issues, along with other relevant issues, were very ably deliberated upon by each of the 8 zonal chapters of IPS in coordination with ICR and SAUs in the form of webinar, which we held in 2021 as a mark of Year of Plant Health, International Year. A total 15 lectures were given, and based on, they were very burning topics on some of these, on the issues which I said. A total of 10,486 participants registered, and lectures were delivered. More than 4,500 have attended these lectures. The major recommendations that emerged from the webinar series have been compiled in the bulletin form and are available in the website, in IPS website. The recommendations will be deliberated further during annual conference of IPS, submitted to ICR and Government of India for implementations for effective protection. So this was what I wanted to say, and I'm sorry I have taken more time because I am into so many things. This is what I wrote in the morning, and I thought what I should say, because otherwise every time we tell whatever we are doing. So these are the new things which many of you might be knowing, not be knowing, but all of you are very learned. Dr. Ashok Singh knows most of them. Dr. T.R. Sharma, he knows everything now, because I am taught all these things by being an ADG there in the when I interacted with them. Thank you all. Thank you so much for letting me give this time. Thank you, organizers. I am one of the organizers, but thanks for having patience and bearing with me. Thank you all. Thank you so much.
So I thank our President IPS, and sorry, sir, I interrupted you because to have the time schedule. So now, yes, thank you, sir. Thank you so much for your address. And now I welcome our Vice Chancellor and Director of IRI, Dr. A.K. Singh sir, to give his address on molecular approaches for biotic drugs management with a special reference to rice. Then sir will share his experience and knowledge with us. Sir, please, sir.
Thank you, Uma. Thank you very much. Dr. T.R. Sharma, Deputy Director General Crop Science, Dr. Chakravarti, Dr. Nayak, Dr. Rasmi Agrawal, all the distinguished participants. I understand there is a constraint of time and Dr. T.R. Sharma has to speak probably. Dr. Sharma, if you have some commitment, you can take a call now and I will come later.
No, please continue for 15 minutes. I just postponed my other meeting.
Okay, I will do that. Maybe I'll complete before that. Thank you very much. I would like to extend a warm welcome to each one of you on behalf of IRI, being the host institution. And I would like to share quickly a few slides that I have prepared for this, particularly on what we have achieved in relation to basmati rice at IRI and some of the general issues. Talking about the molecular approaches for crop health management with a special reference to rice, this is a broad outline of the presentation, and the losses were very eloquently described by Dr. Chakravarti, and this is really very, very important that if the annual genetic gain in crops that we are looking for is about 0.8%, but the losses are 20 to 40%. Now you can imagine so much money is being invested on achieving a genetic gain of 0.8%, but to prevent the losses of 20, 40%, the investment is not so much in terms of developing infrastructure for preventing these losses. If that is done, probably a lot of problems of food will be solved in terms of quality and quantity. Then the other aspect we look at is the economizing the cost of cultivation. For doubling farmers' income, one is reducing the cost of cultivation, other is providing remunerative prices. On average, about 1,000 to 2,000 crores is annually spent on basmati rice and pesticide. In this calculation, we were doing when Dr. T.R. Sharma led a project with the mentorship of Professor Sridhar. Both are here and very happy to see them. And we were doing this justification why there is a need to have a specific breeding program for disease resistance. For basmati alone, this was the kind of loss predicted. And to address this issue, we need a systematic approach where we have the assessment of severity of disease, characterize the pathogen variability, look at the availability of differential sets. If they are available, then we can straight go for mapping, tagging. If not, that has to be systematically achieved in order to facilitate the breeding program. Rice, we have been very fortunate because of the global efforts made at IRI and several other places by Japanese, by Chinese, in terms of discovering large number of genes, mapping them, identifying their chromosomal locations. In bacterial blight, 42 genes mapped, blast 118 genes, and more than 350 QTLs have been mapped, and 25 blast genes have been cloned. Dr. T.R. Sharma is the one from India. The first cloning came for the PI54 gene, which has been deployed in the breeding program largely. So these are the major genes in case of bacterial blight: 5, 13, 21, 33, 38 deployed. In blast, we have PI9, PI2, PI54, PI1, PI54, and you can see the crop here on the this corner suffers from bacterial blight. A number of these genes have been deployed to prevent these losses. We have been using molecular breeding extensively at the Indian Agriculture Research Institute, and this has led to development of a series of products. The first one was improved Pusa Basmati 1, led by our Director General, Dr. Mahapatra, and where XA13, XA21, two genes were pyramided through molecular breeding program. And then, there was a need to have a guideline, and that's where the role of, the crop science division is so important. And Dr. Sharma is looking after it very systematically. that guidelines were developed, implemented for release of near isogenic lines because they are developed in the background of established variety, released variety, and therefore in place of testing them for 3 years, test only for 2 years and release it. And maybe if we develop a system where we can have very large scale evaluation, multi-location evaluation, even 1 year testing is sufficient. Another criteria is still that exists in this guideline, which needs a revisit, is that these essentially derived varieties or near isogenic lines should have at least one character that makes them different from the original variety. Now, when we have the markers for the character added, the markers should itself be sufficient. We should not look into a character difference, something that can be looked into. So several other examples of molecular breeding for incorporation of genes for resistance to bacterial blight and blast in different varieties. One of the major problem has been is the blast, and this is a field of infected with neck blast. You can see excellent crop of a potential of 7 tons per hectare, Pusa Basmati 6 variety in Panipat district. But at this stage of pencil formation, when the neck blast comes, the pencils droop down because of broken neck and crop completely dries. Tricyclazole was a pesticide extensively used to control this, which has been banned in European Union. Almost banned because its level has been brought down to 0.01 ppm, 1 milligram in 100 kilogram of rice. Difficult to achieve, it is the detectable limit of equipment. So the only possibility is to have the resistant genes deployed, and that is where this project which I was talking about, Dr. Sharma initiated, with the funding support from the NAIP. And we had a major project to create isogenic lines in the background of Basmati variety, Pusa Basmati 1 for major blast gene, PI1, PI54, PETA, PI5, PI9, PI2, PIB. And all these genes, near isogenic lines, 1 gene, 2 gene, 3 gene, 4 gene combinations have been developed, and they are available in the Basmati background. And this is how these nils they look like. And one of the genes when PI9 was added, one variety with this gene, has been released for commercial cultivation. The donors for PI9 was very bad: red pericarp, chalky grains, grain swells on cooking. To get rid of these bad characters was really a challenge, but then this was possible. And this variety, you can see how a single gene can make a difference. This is Pusa Basmati 1 in Milan, in the uniform blast nursery, completely killed. And same PI9 gene added in Pusa Basmati 1, nothing happens to it. So that is the kind of protection that it provides, and the variety release was Pusa Basmati 1637. And this is a variety in Pusa Basmati 1 segment, and that's the major market for European Union. Likewise, we have developed another variety, non-Basmati segment 1850, deploying PI54, PI1, PETA in Samba Masuri background. And this variety is doing so wonderful. Average yield of 8 tons per hectare from large scale farmers field this crop season. I have got the data. And there is a good scope for this variety because Samba Masuri was going out of cultivation because of its blast susceptibility. Also, XA13, XA21 deployed in 1121, and this variety 1718 has been released, which is almost now 50% replacement of 1121 it has provided. Wakane is a major problem. Where the plants, because of the gibberellic acid, they grow tall and ultimately they dry. The field looks very ugly. There we initiated a mapping program. It occurs in Haryana, also in UP, less in Punjab, but it's a very severe problem. We started develop protocol for screening, and then by seed inoculation, and then finally the gene was mapped, tagged, and deployed in the breeding program. So now we have material which is available for assistance to Wakane as well. The new and novel strategies which can in fact address many of these problems, and I'm sure Dr. Sharma is going to address these issues in his address. The genome editing is a powerful tool. For example, if you just cite you a case of XA13 gene, recessive gene for bacterial blight resistance in rice, almost 90% varieties are susceptible. And XA13 is a recessive gene. We have resistant sources available, but to transfer through backcross breeding, it takes time. You get a lot of linkage drag and so on. In this case, now any variety that you pick up which is susceptible to bacterial blight, which does not have XA13 gene, you can do targeted genome editing of XA13. It's a tail effector mediated resistance. The series of sweet genes, sweet 11, sweet 13, sweet 14 have been identified, and they can be altered by genome editing to convert a variety into resistant. A ready-made product will be made available. So these are the kind of possibility that genome editing offers in future. And one clade-free genes, they are very much covered by they are in the category of sweet genes, and they can be easily altered. The sweet gene family, there are a number of families, but one family in clade-free is amenable to bacterial blight resistance development. Other aspects are like discovering of new molecules for chemical management. This is one area where we have been lagging behind. Dr. Chakravarti very eloquently brought out this issue in terms of research. We hardly have any lead on this, and this should be a major priority. Discovery and utilization of biologicals again. So far, biologicals have been used here and there, but then the kind of stringent quality control that is required in their isolation, characterization protocol, and also commercial formulation needs to be done. And then novel delivery strategy using nano formulation and vaccines, strong and effective network for surveillance. And currently in our breeding population, the frequency of desirable allele is very less. So this has to be enhanced so that, this is a scheme of genomic selection where the favorable alleles, if they are floating in population, then your product development would be much easier. Time of development for variety, integrating, double haploid, speed breeding, and short duration donors, this can be accelerated. Many genes have been identified for, resistance to different biotic stresses. But in terms of mapping genes, cloning, characterization, that is one part that is missing, which needs to be really focused. And in addition to that, I think a comprehensive approach is required for addressing the problem of losses that happens because of the insect, pest, and diseases. Minimize the use of pesticide and safe use of pesticide. I was told, I was visiting the Mariperu station in Andhra Pradesh, and some Japanese have come out with the formulations in terms of insecticide where you just do seed treatment, and these formulations, they last to the harvesting of crop. That's the kind of efficacy and delivery system that is required. Definitely this will bring in the safety, it will reduce the cost of cultivation and enhance the productivity. With that, I would like to thank you very much for giving me this opportunity. Thank you very much. Yeah, over to you.
Oh, thank you, sir. Thank you, sir. Sir, because of your well-coordinated and multidisciplinary approach, you have achieved, especially in rice breeding program, sir. Thank you for your sharing your knowledge with us, sir. Now, thank you, sir. Now I welcome our DDG, Crop Science, Dr. T.R. Sharma, sir, to address this gathering. Sir, please, sir.
Good morning to all. Am I audible?
Yes, sir.
Yes.
Okay. Thank you, Dr. Uma.
Yes, sir.
Honorable Member ASRB and President IPS, Dr. P.K. Chakravarti. My colleague, Dr. A.K. Singh, Director IARI. Dr. Nalathambi, President IPS Southern Zone. Dr. R. Sridhar, our distinguished mentor. Dr. S.R. Niranjana and Dr. M.K. Naik, former and present Vice Chancellor. Distinguished participants from Southern Zone of IPS, colleagues, ladies and gentlemen. First of all, I would like to thank you all for inviting me here for this very important meeting of IPS, which is a great tradition, which at least IPS is following for the past so many years. I also forget to address Dr. Rasmi Agarwal, our colleague from IRI. She is here. So Dr. Agarwal, welcome to this meeting also. I don't know what to say at this point in time. Dr. P.K. Chakravarti has very elaborately told what a plant pathologist should do and what not to do, and followed by Dr. A.K. Singh, a very elaborate study which has really created a revolution in resistance breeding in case of rice. Frankly speaking, I was talking to even Dr. Chakravarti that after my PhD, I never got a chance to read or teach plant pathology at any point in time. Starting from my career at Agriculture University, Palampur, I used to teach introductory in plant biotechnology and disease resistance. So I don't know how much I would be able to say at this point in time, but my area of expertise is disease resistance and genomics. That's what probably you know. And that's where I have started working from my PhD days, transferring genes from different wild species to cultivated one in Brassica species, which nowadays we call it pre-breeding. We used to call it interspecific or intergeneric hybridization by using different biotechnological approaches like embryo rescue, ovary culture, ovule culture, and many other techniques which I used to do during my PhD. So my knowledge of plant pathology discipline as such would be very limited, but I would like to tell some of the things which I could recollect during these 2 days, which when I got a invitation from Dr. P.K. Chakravarti and also Dr. Nayak that initially I was supposed to join another program at your adjacent institute, SBI Coimbatore, which they are waiting now at 11. But because of the insistence of Dr. Chakravarti and Dr. Nayak, I could not say no, because naturally you have to sometime away your friends and old colleagues like Dr. Chakravarti, to whom I know since his PhD days. Even another day I was telling him that I still remember how he used to sit hours together in front of autoclave to autoclave his medium at HPKV Palampur. So those were the days when technologies were not much advanced. But coming to the subject now, as very rightly pointed out, and the title of this symposium is also Advances in Crop Health Management, which is very important topic nowadays. And we know that plant pathology discipline itself started with the Irish potato famine, which was caused by late blight of potato in 1845 to 49, as rightly pointed out by Dr. P.K. Chakravarti. But many of you probably don't know that it was only because of vertifolia effect, that is genetic uniformity of a single cultivar of potato, which was being grown in Ireland during those days, and single race when appeared on those fields, it completely wiped out the potato crop and created famine in that. If you see the history of plant pathology, I am sure the old plant pathologists, they might be knowing. I don't know whether these vertifolia effect and genetic uniformity and vulnerability is being taught in your subject or not, but we were taught all these things in our BSc agriculture. So followed that, there was a Bengal famine. We all are aware of that in 1943, because of, again, a single disease, brown spot of rice, and which created large-scale famine in India. And we know that there was a huge crisis during those days. But coming to the field of disease resistance, those who are familiar with the literature, they might be aware that once Mendel's laws were discovered and rediscovered in early 19th, in case of peace, those were first tested in case of yellow rust of wheat, when Wiffen in 1905 very clearly told that inheritance for yellow rust of wheat is controlled by a single recessive gene. That's where people started thinking on these aspects as far as disease resistance is concerned, that resistance trait in many of the host pathogen system, particularly in biotrops and hemibiotrops, followed a typical Mendelian pattern. And then many of you might be knowing, and our member ASRV, Dr. P.K. Chakravarti, used to ask this question about Floor's gene for gene concept, which came in the year of 1945 and again compiled by H.H. Floor in 1971 Annual Review of Phytopathology. And that's a classical concept where it says that for every gene conditioning resistance in host, there should be a corresponding A virulence gene in a pathogen. When R and AVR interact, that leads to resistance phenotype. That's a typical gene for gene hypothesis, which hold true in many host pathogen systems, not only in plant pathology, but also even in human. And our whole breeding for disease resistance concept is based on this particular hypothesis, which was given by H.H. Floor at Wisconsin State University by using Melampsora linnae and linseed rust without any molecular biology techniques. So you can imagine in 1945 and 44 and 45, and nothing, no molecular biology techniques, but even DNA was not discovered. This concept was given by H.H. Floor, and we all are using this particular concept. And based on this particular concept, many genes for resistance were cloned, and many of you might be knowing that first gene for disease resistance was cloned in 1992, HM1 by Briggs and Johal in maize. So you can now, if you start thinking from 1905, when inheritance of resistance was discovered in case of wheat, it took more than 90 years to clone and characterize a resistance gene. Because in this particular case, we don't know the resistance product. We only identify a gene from its phenotype. And when you know any gene from its phenotype, you cannot use a typical molecular biology technique wherein you can just design primer and synthesize the primer and amplify the gene. Here you have to use map-based cloning approach, and linkage map has to be developed for this particular mapping and cloning. Then followed by PTO 1993 in tomato, genes for Pseudomonas resistance was cloned, and in 1999, first gene for resistance was cloned in case of rice, for rice blast. And in 2000, PITA was cloned by US worker, and then followed by our gene PI54, which was the third report in literature which we cloned at IRI New Delhi, about which Dr. A.K. Singh has told. And it took us around 10 years to clone this particular gene, starting from 1996. Our first paper came in 1905. So people may think that science is very fast and quick. Nowadays it's very fast. You do transcriptome analysis, give some sample to a company, analyze that data, and within a year you get a paper or good publication. But for publishing a paper in mapping of resistance gene, for us it took around 9 years. And then in 2005, we cloned this gene, developed DNA markers, functionally validate it, and also now it has now transferred in more than 35 varieties of rice. Many examples Dr. A.K. Singh has already given. That has now created a silent revolution in resistance breeding as far as blast disease is concerned in rice. But now I would like to take you to different side of resistance mechanisms. If you remember, there was a plant pathologist, J.E. Vander Planck, who wrote first book on plant diseases in 1962, when he gave the concept of vertical and horizontal resistance. Many of you might be aware, we are using vertical resistance when we incorporate resistance gene in a host, okay? Or we pyramid one or more than one genes in a particular line. It's a vertical type of resistance which completely stops the spread of a pathogen. But when you have minor genes in host, then that is called horizontal resistance, means you have partial resistance to a pathogen. So it has genetic connotation when you genetically define horizontal and vertical resistance. It gives you a very clear-cut idea. But I want to tell you another important concept which Vander Planck gave in his another book in 1978, that is Genetics and Molecular Basis of Plant Pathogenesis. In that book, he gave the concept of genes for susceptibility. And there was two schools of thoughts during those days. One was led by H.H. Floor and his follower, those who were saying that resistance is controlled by dominant and recessive genes, and there's nothing called as genes for susceptibility. But during those days, we were taught that Vander Planck was saying that there are genes for susceptibility in host which attract pathogens and provides media for its germination or growth of the pathogen, means for sugars, then amino acids and proteins for the colonization and germination of pathogen on the host. And those are because of all those susceptibility genes. Now, my friends, if you are following literature, the first genes for susceptibility has now been targeted by using CRISPR-Cas9 sweet gene, again in case of rice, which is XA13, and sweet gene is genes for susceptibility, which has now been proven with no doubt that there are genes for susceptibility in host. So now we have two different approaches to manage. We can use either genes for susceptibility to manage plant diseases, or we can use genes for resistance, which Dr. A.K. Singh has presented for management of plant diseases. So these things have evolved with the evolution in science, particularly in molecular biology and molecular plant pathology. That's why we if you know the literature and follow literature, typically first genome for crop plants was decoded in 2005. It was rice, and we all were involved. We were involved in decoding the genome of rice. And when we analyzed rice genome thoroughly, if you see our paper, we found that more than 700 genes for disease resistance are present in case of rice, and many of them are present in cluster on different chromosomes. And more than 200, around 168 defense response like genes are present in rice. Many of them are present in clusters. But during the same time in 2005, genome of Magnaporthia oryzae, that is the fungal genome of rice blast pathogen, was also decoded, and both these papers appeared in Nature simultaneously. The genome of rice, okay, also appeared in Nature, and genome of rice blast pathogen Magnaporthia oryzae, whose size is around 38 million base pair, also appeared in Nature. And in that genome, many A-virulence genes were also decoded and also characterized in the genome. Then we thought that why don't we prove the gene for gene hypothesis, which was given by Floor in 1945 in case of rice. So looking at the AVR genes, then we started working on it. And if you follow our papers, then one of our students, he cloned genes, A-borreliose genes from Magnaportia rice. And then we joined these both the genes together, put in a simple host, and then created resistance phenotype. And we showed very clearly that the resistance protein from PI54 and A-virulence protein from AVR PI54, when they physically interact, which we showed very clearly by using Is2 hybrid system, that when these both interact, it leads to resistance phenotype. And if you follow the papers of our honorable member of ASRB, particularly the plant journal paper, he has cloned many AVR genes from gentlemas, if I am not wrong, and published in plant journal. So one has to see how this field has evolved now. But looking at our all programs of AICRP, I evaluated all our AICRP program now around 26 different crops, except wheat and rice. No one talks about resistance genes or resistance breeding. That's very unfortunate. No one talks about pre-breeding except wheat and rice. And we have little work in case of pulses. So that's why now, if you see all these AICRP programs which we have made now, and also our EFC which we are making during these years of across the institutions, crop-based institutions, pre-breeding is one of the most important component which we have kept now. And Dr. A.K. Singh knows that. Many of you, the directors sitting here, they know that that has made mandatory now in all the crops. And even our honorable DG is always emphasizing the pre-breeding concept. It's not a random pre-breeding. It's a directed pre-breeding. We have to see in wild species the important trait first, whether for disease resistance, whether for quality traits, or whether for some abiotic stresses, and then do pre-breeding. That is called directed pre-breeding. And then using molecular markers and mapping genes, developing mapping populations, and then mapping genes, one can go to the using of approach of marker assisted selection. That's where one has to see. So that's where plant pathology is moving now. But as rightly pointed out by our first speaker, Dr. Chakravarti, we don't know even yield losses of different pathogens. In many AICRP, I asked this typical question, and all those plant pathology, I have given a project that now it should be inbuilt in their AICRP program to estimate the yield losses of different pathogen and pest. Unless we don't estimate these yield losses, how can you show their significance? So the very, very important things which are coming into discussions during these conferences and also during such type of meetings, but probably as told by our earlier worker, theoretically we are following, but practically let me ensure here, Dr. P.K. Chakravarti, that at least now we are following in crop science division in all these aspects which you are told, particularly estimation of yield losses, use of new biopesticides, and whatever we taught in theory should be practically implemented in crops for disease resistance. And that's where probably I was thinking to bring out these issues, particularly the biostimulants, which was talked about by Dr. Chakravarti, RNAi and host delivered RNA. Very important aspect. Our 2-3 papers have come on these aspects. Then finally on genome editing, as I gave you an example of editing of these genes for susceptibility. Once you edit gene for susceptibility, that will be everlasting resistance, because the pathogen has a limited chance to mutate against the resistance mechanism, which they easily mutate against resistance genes. That's why we always emphasize to pyramid more than one gene atypical background. And now if you see, the field has moved further, which our member, Dr. Chakravarti, has done long back, effector biology and use of effectors in disease resistance. It has now came up in a very big way. If you see the literature, Google search, effector biology has come in a very big way because many of the pathogen genomes have already been decoded, and also those effector protein or secretory protein which are being released by pathogen within a host cell, how that leads to susceptibility or resistance, this mechanism is being understood by many workers, and our lab is working on these particular aspect. Now recently my PhD students are working on these particular aspect, how to know and characterize these effectors which we can clone from different pathogens. So for all these things, I think human resource development is the basis for everything, and teaching has to be very strong. And I'm sure the IRI, which is considered as one of the oldest department of plant pathology in India, should take lead in all these advanced areas of science. And I would like to say at this point of time, because it's a society meeting, try to improve the impact of your journal. It should not be, you should not always look for mass rating. It should be international impact factor which matters. And unless you work hard, unless you are vigilant while selecting papers to be published in this journal, I don't think this journal will grow. And I am sure that with the guidance of Dr. Chakravarti, and who is the president of IPS, the journal should also take in different shape and should be recognized internationally, although it is being recognized internationally. As far as its impact factor is concerned, it's below standard as far as our science is concerned. So with these words, now I would like to stop here. I have to go for some other meeting in SBI Coimbatore, which is adjacent to you. And thank you very much. Best of luck for your meeting. This is one of the very important topic you have chosen for this particular meeting. And I'm sure that rest of the meetings, zonal meetings, which are very important in IPS, would be like this. And I wish you all the best, Dr. Narathambi and your group, for organizing this meeting at Wellington. We should not forget the contribution of Wellington and the vaccinia path which we have got. And unless we test our weed material at Wellington, it is not passed for further release. So it's very important research institutions for us in crop science division and also at IRI. And we should always say with a lot of pride that we have such institutions exist in the country like Wellington and Flowerdale, Shimla, which are keeping track of all the new races in wheat rust. That's why there is no wheat rust epidemic in Deer Park, recent past. So thank you very much. Thank you all. Thank you for giving me this opportunity, and wish you all the best for whole deliberation. Namaskar.
Thank you, sir. Thank you very much.
Thank you, sir. I thank our DDG. He accepted our invitation, and I welcome him and I thank him for his good address on different approaches, on different molecular approaches for host-resistant mechanism, and his concern about the emphasis to do pre-breeding in other crops other than rice and wheat. I thank you, sir, for your encouragement and support for us to conduct this virtual symposium. Thank you, sir.
Madam, you can move on to vote of thanks.
Yes, sir.
Running out of time.
Yes, sir. Yes, sir. Sir, a warm good morning to everyone. Now I thank our DDG, Crop Science, for his address and his support. firstly. Then I thank our Vice Chancellor and Director IRI, Dr. A.K. Singh sir, for his encouragement and his concern and his constant source of encouragement and support for us to conduct this one virtual symposium. And next, I thank our IPS Secretary, Dr. P.K. Chakravarti sir. Whenever we needed his guidance, he is always there to give his guidance to us. And next, I want to thank our Secretary, IPS Dr. Robin Gogoi, and he is the organizing chairman for this virtual symposium. And he is, I'm thanking him extremely for his well-coordinated efforts that has helped us to make this symposium a success event. Then I extend my thanks to Dr. Rashmi Agarwal ma'am, head of the division IRI, and also Dr. Malkan Singh, Dr. Kalyan Mandal, and Raju for their continuous efforts to make this one success. Then I am very grateful to our seniors like Dr. Viswanathan sir, Dr. Selvarajan sir, and Dr. Tangavel sir. They were our inspiration in our college days, and still now we are getting all type of guidance from them. And I thank our seniors for supporting us. And I thank our colleague Dr. Magesh Kumar as well as Veena for their technical support. And I thank Dr. Devappa from Karnataka and Dr. Sajina from Kerala. They encourage the young students to register in this symposium. And I thank sincerely to our head of the division, Dr. M. Sivasamy sir, for his support. And I extremely thank Dr. Berlin and Anjunan for their technical supports from the beginning of this virtual symposium. I extremely thank them, and I thank our young professionals, RT and Priya Ravikumar. And I thank Dr. Niranjana sir and Nayak sir and all other delegates who responded well and coordinated us for this event. And finally, I thank all the members, especially the members of South Zone IPS. This one. Then I thank one and all for their good response, and all they made this event very successful. I thank once again DDG Crop Science and our director and heads of the divisions and all office bearers and zonal councillors of various zones of IPS and our president IPS. Thank you, sir. Thank you so much.
Yes, sir. Thank you all. In fact, I would have invited you if you are organizing the same meeting at Wellington, Nilgiris, with a wonderful tasty tea. But unfortunately, we are far away. And thank you all. And let us have a break. And the next session will start sharply, maybe another 15 minutes. Thank you very much, sir.
Thank you.
I request Dr. Niranjana sir to kindly coordinate with all the lead speakers, the keynote address persons. Thank you, sir.
But people will disappear, Nalathambi. Why, if the tea is not there, why don't you continue?
Yes, sir.
You
If you
continue,
want to
there is
have
no
break,
tea.
you can.
5 minutes break, not more than that.
Okay, sir.
15
Please,
minutes
sir.
is high time.
Yes, sir. Yes, sir.
Because since there is no tea, don't leave for 15 minutes. Otherwise, people will disappear.
Okay, sir. Please, sir.
Yeah, 5 minutes. It's a
The
5
link
minute
is
break.
same, na? That's why we can continue.
I think you can continue.
Okay, sir. Please, sir.
Yeah. Can I continue?
Sir, you can go ahead, sir.
Okay. Yes, almost we are reaching. Good afternoon, my dear participants. My New Year greetings to all of you, all South Zone participants who are participated in the South Zone conference, which is organized by Professor Nalathambi. I think in my responsibility, there is 4 speakers, including President. 3 keynote speakers are there. I think all the 3 keynote speakers may be present there, and President is also there. We will distribute the time, 15 minutes each, and presidential remark and keynote address. Normally, we don't have any questions. There are no questions in presidential address and usually keynote address. So we are distributing a time of 15 minutes for each participants. So my co-chairman, Dr. R. Selvarajan, I think he is present there. And report here, Dr. C. Bindu Rai. She is also
Yes,
there.
sir. Yes,
And
sir.
report here, Sri Berlinier. I welcome all of you for this particular important session of keynote lecture series, including presidential address. So now I request Professor Nallatambi, President of the South Zone, and also I congratulate them to organizing in this situation for the South Zone Conference. He has taken all the interest and making all of us have a login for the program. And I request Dr. Nallatambi to give your presidential address for 15 minutes. And after that, all the three speakers are 15 minutes of keynote address. Now,
Thank you, sir.
Nallatambi, dias to
Yes,
you.
sir.
Okay.
Thank you, sir. Thank you very much for this opportunity. In fact, I was thinking to give this presidential address at the end of the session because we have to give the time to the other speakers because we invited the people from different parts of the country. But however, it's a customary that I have to deliver the presidential address.
Yes, yes.
And we have taken the new topic that the challenges in culturing, race analysis and genetic analysis of the wheat powder pathogen. And just now our Honorable DDG and Director IRA has pointed out that the new diseases or challenging diseases has to be addressed. You know, the powder mildew disease is becoming very important in wheat, except the rust and head scab, of course, the leaf blight and Indian wheat varieties. And there is no dedicated research program in this country to investigate the pathogen. Of course, its host and their interactions. Because we don't have any cultural methods or the artificial culturing methods like any other necrotropic pathogens. Because of this, we are not able to study the particular pathogen biology. So unless you know the pathogen's biology, it's very difficult to go further. Therefore, we have taken up this piece of work at our station in collaboration with our sister organization like the IRA Regional Station Shimla and the leading institute, that is Indian Institute of Wheat and Barley, Karnal. And therefore, since we don't have the knowledge about the pathogen, it is very difficult to ascertain the variability and it's the virulence pattern, particularly on the commercial varieties, because we are encountering the disease very often, particularly during the off season in our most of the commercial cultivars. And we don't know what is the race profile or how many virulent races are there. All these informations are lacking. So the races and pathotypes are not documented except the virulence pattern or the virulence isolates against particular origins like PM1, 2, 3, like that, etc. Therefore, unless this pathogen is not studied thoroughly, and it becomes difficult to develop the resistant varieties. And few of them are getting escaped due to unfavorable conditions. All because of that, we are not inoculating the respective pathogen in the respective host, like in case of rust and other disease, and therefore we are getting the disease escape. And for the information of this audience, for the first time, we have standardized an artificial culturing technique at Wellington because we took the advantage of the Wellington. It's a very cool and nice climate for all the biotropic pathogens, and therefore, at natural condition with a slight modifications, we have standardized the artificial culturing technique. Now we are very confident that any number of isolates could be cultured and maintained at our place. And this is a simple and facility we have created, and we are very grateful to the Department of Biotechnology who has funded the project readily with a multi-institutional approach. And you can see this is the controlled condition polygons structure we created at Wellington. And we have the automatic controlling system for the humidity. You know, the powder mildew pathogen, one of the very tricky pathogen which needs the very critical humidity and the temperature. And we could artificially culture it with the aseptic condition. We are maintaining large number of isolates. You can see this wonderful colonization of the pathogen on the seedling. And we took the advantage of the methodology which is already derived for the rest. And you can see that the single primary leaves are used for culturing the pathogen. And the last slide, you can see that each seedlings or each line has the different genes, that is powder mildew resistant genes, PM1, 2, 7, 8, like that. You can see the differential reaction on the same set of conditions. So by taking this advantage, we could at least purify about 250 isolates from the different parts of the country. And for the information that we are even more than 2 years, we are able to maintain this culture. And I think nowhere in the country, the powder mildew pathogens is able to maintain the host plant. And simultaneously, by using this methodology or technique, and we identify the host differentials. In fact, we have imported these host differentials from the CIMIT and of course our own cultivars from India. And we could make 3 set of differentials similar to the rust pathogen. And based on the differential reactions, then we have moved upon to the further shortlisting pathotypes or the isolates. And now we have the genetic data. So far, we have submitted about 129 sequences in the NCB database. And in my knowledge, I think this is the largest submission in the database for the powdery mildew pathogen, particularly in case of wheat. And subsequently, we have done the genotyping and we have shortlisted. And we could, interestingly, we could see that the second point, the genetic diversity among the different isolates, because we have collected the isolates or the pathotypes from the southern hill zone, northwestern plain zone, and of course the northern hill zone. That is where the Palambur or Shimla area is covering. So, and we also studied the haplotype analysis, that genetics of the pathogen, and we could find that 53 haplotypes group were identified among these pathogen. And this particular work has been supported and done by the collaborating institute, that is Indian Institute of Wheat and Barley, Karnal. So you can see that the phenotyping variability in terms of infection potential among the powdery mildew pathogen was ascertained. And we have worked out the percentage gene efficacy of the different resistant genes by using our own set of host differentials. And based on the value, the efficacy or the documentary value, we could group the clades, 7 and 4 clades from the differential host lines. Now, the most of the virulent rays are covering the clade 2. And this has given very good information or indication for us that we are very confident that we could be able to formulate or constitute the differential host differentials for the analysis of the powdery mildew races in this country. So the genetic analysis is resulted the pathotyping. We could differentiate the pathogen or the pathotypes from the Shimla as well as the Wellington or even the northwestern plain zone. And this is the molecular data in the nutshell, because part of the shortage of time, I could brought it in nutshell that the haplotype analysis was carried out, and we could see that the Shimla region isolates or the virulent patterns quite different from the southern parts of this country. So with this, the genetically distinct the Plumeria graminis or the powdery mildew pathogen were selected for the further race analysis, and we are very comfortably on the way for the generation of the whole genome sequencing the program. So with this, let me thank. I'll give the time to the other speakers because we have invited them. I thank you one and all. Thank you, sir. Thank you very much.
Thank you very much, Professor Nalathambi, for your presidential remark. And you are very voluntarily given the time for others. And now I will request the keynote lecture, one by Jairaj Jairaman, Department of Life Science, Faculty of Science and Technology, the University of West Indies, St. Augustine's, this Tobago. He is going to speak on efficacy of algal bioelicitors in horticultural crops, a case study. Professor Jairaj Jairaman, your time is 15 minutes. Please take the dais.
Very good morning to everybody. And thank you, Chair, for the opportunity.
Yeah.
I was earlier told for 30 minutes and I prepared my presentation for 30 minutes.
No problem. You take 5 minutes, more or less 20 minutes.
Okay,
Yeah.
I'll try.
Yeah,
I'll try my best.
Yeah.
Thank you very much. And
this
yes, let me turn on to power presentation mode. Yes. Could you all hear me, please?
Yes.
Yes. Very good. Thank you very much. Yeah. Again, a pleasant good morning to you all. I am at 2:15, Eastern Standard Time. Okay. So it's a pleasant experience for me to be with you all, and thanks for having me in this August symposium. I'm here to talk to you about one of our exciting projects, which is currently ongoing.
Dr. Jairaj, can you put your slide in a full slide mode?
Yes, I have done that so.
Okay, right, okay.
Could you see the slide?
Yes, very
Okay,
much.
very
Please
good,
go ahead.
Very good. Yeah. So one of the current projects, and this is not just only one area, but this is one of the thematic areas of our research group, and we are able to progress so much thanks to the funding we have been receiving for past years. Nearly 10 years I've been in this area of research, that is just to identify elicitors, bioelicitors from seaweeds. Seaweeds here, I mean the algae, the macroalgae. Earlier, I have been focusing on the brown kelp, which is Ascophyllum nodosum, also called as Atlantic kelp. And we have identified several elicitors, and we have been working with a company in Canada, and we have been partnering with the company to identify and to utilize the commercial potential of these elicitors. And after moving to Caribbean, I've been focusing on Caribbean seaweeds. And here I'm going to talk to you about a couple of Caribbean seaweeds which have been available plentiful in this area. And we have developed certain formulations out of these seaweeds. And I just want to share with you some of our exciting results. So my name is Jaya, and Omar Ali is my graduate student, and Dr. Adesh Ramsubag is my co-PI, and both of them wanted to be with me. Due to the time difference, they couldn't be. But anyway, they wanted to say their regards to you all. Thank you. Right. Just to move along with the presentation, why we need to use seaweeds? Because seaweeds is one of the renewable bioresources which is available in plentiful in Caribbean. And we have more than 100 seaweeds. Most of them are brown seaweeds. And there are 3 different types of seaweeds: brown seaweeds, red, and green. And we have plenty of brown and also some red seaweeds. It's a underutilized bioresource. And recently we have a big menace caused by sargassum. We are getting tons and tons of sargassum coming from South America, and the entire Caribbean Sea, as well as the islands, are plagued by this problem of sargassum landing. And this has affected the tourism industry as well as the fishing industry, and it completely spoils the biodiversity of the our marine areas. And so we have been in this process of developing inputs, particularly for crops. And these inputs have been labeled as organic inputs because no chemical has been spiked into it, and they are mostly kind of native and also very organic and useful for organic agriculture. And by utilizing these seaweed derived inputs, and many of them have been commercialized, and they are freely available in the market, we may be able to reduce the use of chemicals, and that will eventually minimize pathogenic resistance, chemical residue, and environmental pollution. And we have gone to the next step of valorization of these seaweed biomass for developing a variety of products which can be used for food, medicinal, cosmetic, and construction industries. This is one example of how sargassum seaweed is landing in the beaches. So the entire beach is gone. You cannot see a beach here. So Caribbean is famous for the virgin beaches. The best beaches are found in the Caribbean, and we are losing our beach atmosphere just due to this sargassum. And we are in a high time to use this sargassum for some other purposes. Right. So based on our experience, and this has been widely published, the phytoelicitors derived from seaweeds have a variety, a plethora of substances, including polysaccharides, oligosacs, and certain osmoprotectants, betaine, sterols, amino acids, tannins, and phenols. And they have a variety of functions. It also includes certain phytostimulant compounds, which includes hormones as well as a little amount of nutrients also.
Here it is, sir.
Excuse me?
Very good morning.
Are you talking to me?
Yarige.
Makesh?
MSc grade December
You continue, sir. You continue. It is interruption.
Okay. Yeah. Right. I hear some cross talk here. So These are all the documented effects of seaweed extract usage. As I told you, the use of seaweed extract has been commercialized, and there are a variety of products in the market nowadays. And if you look at their effects, it's just it improves the nutritional ability and the mobilization of nutrients, improved water efficiency, improved disease management, and improved soil fertility. These are all the two weeds I'm going to talk about today. Even though we have screened more than a dozen seaweeds and identified 6 very potentially important seaweeds, and we are going ahead with these 2 seaweeds because these two weeds are available in abundance, particularly the first one, this is Sargassum vulgar. We have developed a method to extract from these seaweeds. It is a cold method of alkaline extraction. And we have optimized that method. And these extracts have been applied to plants as a foliar spray in different crops. Here we have used 2 model crops, sweet pepper and tomato, in the field as well as in the greenhouse condition. And we did bioassay for plant growth and induced disease resistance and assessment of molecular mechanisms for induced resistance. 1 second, please. You know, I couldn't read because of this. Yes, let me reduce it. Right. So this is the results for greenhouse severity trials. So we have inoculated 2 pathogens, a bacterial leaf spot and the early blight, so 2 different pathogens in both sweet pepper and tomato. And we uniformly saw a higher reduction of the disease incidence in both crops due to application of these seaweed extracts. This is Ascophyllum. AS means Ascophyllum. Acanthophorus piscifera, and SV is Sargassum vulgar. You can see similar results in both crops by these diseases. And we did measure some of the parameters, growth parameters. And here also we see a consistent improvement in the yield as well as dry mass production as well as the plant height and chlorophyll content due to application of the seaweed extract when compared to the fungicidal control. And this is about the floral parameters. What we noticed, interestingly, it's not just for these seaweed extract alone. For most of the seaweed extract, we noticed early flowering, early appearance of the flower buds when compared to the control. And that is maintained for the course of time. And we also noticed an indeterminate flowering. That means the plants keep on flowering for a while, even up to the, the clearance of the crop. So farmers have to keep the crop for a little longer than its duration. And this is some of the results of the field trial. We have done extensive field trials, and here I'm projecting the results of only 2 field trials. We did 2 consecutive field experiments using the seaweed extracts as well as the fungicides in 2 seasons, that is a wet season and dry season. In the Caribbean, we have only 2 seasons, wet season and dry season. And in both seasons, we found more or less contiguous results, wherein the application of seaweed extract has improved the health of the plant, meaning that the disease incidence was significantly reduced, and we got the best reduction of the disease by adding a little amount of fungicide, 1 dose of fungicide. That means 2 sprays of seaweed extract for every 1 fungicide spray.
Yes.
Reduce the fungicide spray by 60%, to 1/3 to 1/3.
Excuse me, Chairman sir, please, you have to mute it. Chairman.
Okay, right, that is not for me. Okay, right. So we have seen this type of trend for both bacterial as well as the fungal diseases. So this is the yield data from the field. Here also, interestingly, you will notice the application of fungicide rather improved the yield capacity of the plants. Even without fungicide also, there was a marginal, it's not a significant, I cannot say it's a marginal, it's a significant increase. But by adding a little dose of fungicide, and these fungicides were, and these are not systemics, these are commonly used and recommended for horticultural crops. So this is the fungicidal control. If you look at the yield, it is sometimes it is double. Okay. So we also looked at the quantification of the pathogen, the real-time quantification of the pathogen, both the bacterium as well as the fungus in the host tissues after artificial inoculation. With the time course, we have compared the pathogen DNA, and we found the pathogen DNA is consistently reducing due to the application of seaweed extract when compared to the control. It's significantly reduced, and that speaks about the reduced disease incidence. We also looked at the antimicrobial activity of these seaweed extracts, and we found there is no antimicrobial activity at the recommended concentration, that is 0.5% spray. And that says that these seaweed extracts are not antimicrobial. They are neither fungistatic or fungicidal. So the possibility this could have some effect on the plant should be due to induced resistance or due to biostimulant activity. So that is a conclusion we could make. But anyway, we have demonstrated how this has happened. So we studied the mechanism of induced resistance and plant growth promotion by looking at the activity of defense enzymes, the defense pathway marker gene transcription analysis, growth hormone gene regulation, the flowering gene regulation, and mRNA sequencing. These are all the results of the marker gene analysis. You know very well the PR1A and the PIN2, that is a PIN2 and ETR1 are the marker genes for SA, JA, and ethylene pathways respectively. And what we found is due to application of this seaweed extract, these genes are induced. Particularly the brown seaweed extract, brown seaweed here means the sargassum, that induced only the JA and ethylene pathway, whereas the red seaweed extract, that is Acanthophora, induced the PR1A gene that is indicative of SA pathway, and also it induces the PIN2 as well as the ETR1, that is the JA and ethylene pathway in a harmonic fashion. That means whenever the SA pathway is not working, then you see the upregulation of JA and ETR1 pathway. This is one of the interesting observations we have observed with the red seaweed, and we have earlier published this despite a lot of controversy, because this is one such compound which can induce both the SAR as well as IASR, but in a harmonic fashion. But they happen at the same time, but in a harmonic fashion. Similarly, we found upregulation of different hormonal genes. Here you can see the expression results of a cytokinin gene, and you can see a substantial increase in the gene expression when compared to the control. And for the IAA gene, you can see both the brown seaweed as well as the red seaweed induced IAA gene expression and the gibberellin gene expression. So that says that all the hormonal genes are upregulated substantially for a significant period of time. This is after one spray. We could see this after one spray up to 96 hours. So in a real scenario, we are applying the crop, the seaweed extract every 10 days or 15 days. So in that case, this upregulation is maintained for over the course of time. We also looked at the activity of defense enzymes. These are all the different defense enzymes which you are very familiar with: the PAL, POD, PPO, chitinase, and glucanase, and these are all the functions. And here also we saw that redundant increase in the activity of the enzymes. All these defense enzymes, which some of them include the PR protein also. So the chitinase, which is a PR protein, we see a very significant increase over the course of time up to 96 hours. and also the glucanase and peroxidase and polyphenol oxidase, glucanase, and also the total phenolic content. We can see a very marked increase in the phenolic content. Since we saw an enhanced flowering or an induced flowering or an indeterminate flowering in the plants, we wanted to know what is the effect of these extracts on the flowering genes. So we selected 6 flowering genes and we tracked the the regulation of these flowering genes in different plant parts. Here I'm just showing you only a pinch of results, and this study was done by one of my master's students, and this has been published recently. I'm just giving you a pinch of results showing what is happening in the buds, but we have different stages, even at the primordial stage, bud stage, flowering stage, and subsequently. And we found a consistent increase in the expression of these flowering genes, the SFT, self-pruning, and jointless genes, and the AN and the falciflora and the concentrance gene over a period of time. So that explains the induced flowering of the plants. And finally, we also wanted to look into the upregulation of all the mRNA, so by RNA-seq. And here you can see these are DEG profile of the mRNAs by NGS. And whatever you see in the blue is down-regulated, and the red is upregulated, and you see as gray is neutral. Okay, so you see a significant upregulation of different genes representing multiple pathways and growth functions. Okay, and this has been upregulated. This has been seen in both sweet pepper as well as in tomato when sprayed with different seed extracts. That is the red seaweed extract as well as the brown seaweed extract. So this is the profile of the tally of the different the differential express gene, the DEG tally, where you can see at least 885 genes are upregulated in tomatoes and 705 in pepper in the case of red seaweed extract, and in the brown seaweed extract we see a little higher number of genes in tomato, and somehow in pepper we did not see that much of upregulation. And this is a functional grouping of different genes, and I just highlighted the important groups of genes representing different pathways. See, the biosynthesis of secondary metabolites, and this is involved in the defense and phenylpropanoid biosynthesis and plant pathogen interaction, genes involved in plant pathogen interaction, and diterpenoid synthesis. And you see a significant upregulation of the genes when compared to the control. And in the case of tomatoes, we saw the similar trend where the synthesis of secondary metabolites, the hormone genes, hormone control genes, the MAPK signaling pathways, plant pathogen interaction, flavonoid biosynthesis, stilbenoids, and these are all involved in phytoalexin synthesis and diterpenoid biosynthesis. And we also, I'm just showing a preliminary result, but we have done already the extensive metagenomic analysis, and just due to the paucity of time, I could not display all those things, but I just put a simple slide, a small slide, how the foliar spray of the extract has a definite as well as an instantaneous influence on the rhizosphere microflora. Here you can see the 0th hour, and then the 2nd day, 5th day, and 10 days. You can see a significant increase in the 2nd day itself. And I'm just showing you the data only up to 10 days, but we have done for 2 months, at 10-day intervals. And we see a gradual increase and also a sustainable increase. It just, the increase is sustained for a long time. This is a total bacterial count on the rhizosphere soil. And we also grouped all the bacteria, and many of them belong to the nitrogen fixers, the phosphate mobilizers, and all these are the growth of these bacteria is augmented by application of the seaweed extract. And the same thing with the actinomycetes, which these actinomycetes offer a protective or a protected rhizosphere, even though their population is not so high. Their presence is very important. And the application of this seaweed extract has a certain influence on the growth of these actinomycete population in the rhizosphere. And we also found that the soil application and the foliar application do not have a significant variation. And in terms of cost, soil application is a little bit expensive. Foliar application is cheaper. So we are advocating now the foliar application, and farmers are taking that prescription, and that is becoming easier and also cost effective. To sum up, these are all the conclusions quick conclusions I could make. The plants treated with seaweed extracts had significantly lower levels of disease incidence in the greenhouse as well as the field in multiple crops that have been tested. And it has been clearly demonstrated that seaweed extracts are not antimicrobial, and they can be truly qualified to be called as bioelicitor. So to call anything as an elicitor should not have a primary antimicrobial activity. In that way, these seaweed extract components can be ideally called as bioelicitors since they are of biological origin. And addition of a small dose of fungicide, because whenever you talk to farmers, do not use fungicide, nobody is going to listen. I think that is in Caribbean. I hope the same thing all over the world. So we need to include purposefully a small dose of fungicide. So we recommend the only recommended fungicides and chemicals for horticultural crops. And we have quite a handful of such fungicides, and we ask the farmers to use at least select two such fungicides, and then alternate these sprays for every 2 sprays of the seaweed extract. And that really worked. And that achieved maximum reduction of that plant disease and also augmented the yields. And this has been proved in different crop models and has been extensively published by our group in the previous, in the recent past. And we also found the DNA levels of pathogens are significantly lowered due to the application of extract, and both pathways, not simultaneously. Only in the case of seaweed extract, there is a modulation of ISR and SAR in a harmonic fashion, but the brown seaweed extract is able to evoke an ISR mediated response, that is J and ethylene pathway. And that leads to the accumulation of defense enzymes as well as the defense proteins, which include different PR proteins. And so interestingly, these seaweeds contain plenty of polysacs. And during the process of extraction, which is alkaline digestion, you are able to release oligomers of these polysaccharides, which are powerful elicitors. And you know very well, oligomers of these polysaccharides have elicitor function. By NMR as well as mass spec, we're able to identify many of these polysacs as well as the monomers of these polysacs. And we have also isolated these polysacs and proved their elicitor function. What I'm showing here is the red seaweeds contain this much of polysaccharide constituents, and the brown seaweeds have there is a difference in the quantity as well as the quality of polysacs. And that speaks out about the type of pathways that they induce. Okay, so for instance, the ISR mediated response is more inclined towards the laminarants. And in the case of carrageenans, they are more responsible for an SAR type of response. So we have evidence for that. Unfortunately, I couldn't present all these things here. As I told you, as a non-specific response, the total phenolic contents increased and the activities of different enzymes are upregulated for a significant point of time. That provides protection to the plants for against infection. And the reduction disease might be due to physiological and biochemical changes elicited by the seaweed extract on the plants that leads to induced resistance. And the elicited compounds are supposed to be polysacs, oligosacs, betanes, tannins, and phenols, etc. The plant growth promotion could be attributed to the cytokinins and auxins, and also the trace levels of micronutrients and macronutrients present in the extract. And we also demonstrated that the flowering genes are upregulated in the treated plants. And the DAG profiles give some strong evidence about upregulation of different genes that is responsible for auxin signaling and cell expansion, lipid carbohydrate metabolism, photosynthesis related genes, nitrogen assimilation and carbon metabolism, and transcription, different transcription factors, and those genes involved in biotic and abiotic stress tolerance that includes disease resistant genes, secondary metabolism, antioxidant genes, phytohormone modulation, and a variety of transcription factors. I'm here just showing you how the extract look like. This is a liquid formulation we have prepared, which is quite wholesome. That means we did not spike anything except for the stabilizers. We added some stabilizers to improve the shelf life of the extracts, and these extracts can be stored without any loss in function and composition for at least one year. And so we have developed this extract, and this has been tested. The shelf life has been tested. Maybe in a year time, this is going to be trade protected and available within the Caribbean. So this is just a picture showing how the extract look like. Okay. These are some of the references, and so this is a project which I have been continuing for a while, but this particular work I am just posting for today's lecture is just only for a period of 3 years I have been doing with the help of my students. And I acknowledge the help of the seaweed research cluster, which we have, and that includes all these students as well as the postdoctoral member, as well as the past and previous students, and co-PIs, my co-PIs, Dr. Ram Subag, and collaborators Adrian and Nigel Jalsa, and the UV plant microbe biota group members, farmers, and the funding agencies. We have not a big money, but a good amount of money from different organizations, and that is how we are able to, continue our research up to now. And very recently, we got we signed up a research collaboration with the French government on a big project where we will be working with the French Caribbean countries, where sargassum is a real problem. Sargassum is affecting the entire tourism industry, and we are going to develop. You won't believe. So starting, we started with the seaweed extract, but now it is going up to making bioplastics, particle board, and up to the pharmaceuticals, because there are several compounds that have been identified which have potential pharmaceutical value. So there are lots of things to be developed out of this sargassum, which is a menace at the moment, but at some point it's going to be a treasure. Once we find a way to valorize this biomass, I hope certainly this is going to be a good commodity which can be valorized into multiple products. And so it can be a curse, but I cannot say it's a curse. It's going to be a boon at some point of time. So with this, I would like to thank you all. I'm just showing you a picture how the mounds of sargassum is accumulating in our beaches, and it's really spoiling the ambience of the beach, and we are losing a lot of tourist revenue. Of course, Trinidad is not based primarily on tourism. We are a petroleum exporting country, but we still have one of the world's finest beaches. But if you look at the entire Caribbean, the economy is dependent on the tourism. So the entire world comes here during summer, and you will see everybody here. But these beaches, the foul beaches, biofoul beaches, are completely shattering our economies, and we are doing something serious to utilize this sargassum in some other way, so that we are clearing these seaweeds, at the same time finding some value, monetary value for these seaweeds. With this, I'd like to thank you all for having given this opportunity, because I am a very old member of IPS, but I am not a regular member to attend all the conferences. But whenever I do visit India, I make a point to attend these conferences. Last year, I've been to IPS, and I was able to meet many of my old friends as well as my past students, and some of them are proud scientists now. I'm so proud of them, and some of them are even present in this group. So I'm so pleased to be with you this morning. Even though it's off time for me, that doesn't make any difference. So time is nothing. So it's all the time what we spend together, and make it useful to all of us. And thank you so much. And I'm so pleased, and I will be available for any discussion, either online or offline. So my email is there, so you can talk to me, and I'll be so honored to take your questions and further deliberations. And thank you very much, and thanks for the opportunity. And I wish you all success in these 2 days of deliberations. Thank you very much.
Thank you, Jaya. It's a wonderful lecture, and you are summarized in a nice way. Because we thinking that the seaweed is a weed really, but you are make use of the seaweed and making a formulations. But keynote lecture normally we will not have any questions. I think Makesh and Jairaj will agree with that. Isn't
Thank
it?
you, sir. Thank you, sir. Thank you, sir.
But I'm asking Makesh. I'm asking Makesh and our Selvaraj. Is it possible to ask any questions to keynote speaker?
No need,
No, sir. Thank you.
Isn't it?
We have to congratulate.
We will congratulate him for good piece of work.
I invite you for a vacation here. Okay.
No problem, sir. No problem. All of us will move. All of us will move.
Please feel free.
It's a wonderful.
Because this lockdown has completely closed our borders, and
everywhere is the same problem. We are also not supposed to move. Yes. Otherwise, we are all would have become in Ooty city to organize this South Zone conference. So we are not able to move.
I know, but I say, Chair, with your kind permission, may I say one word? This is a blessing in disguise for me, because I was not able to attend all these South Zone meetings or the IPS meetings. And this is a golden opportunity for me.
Thank you.
to show off, by online. So I think online has plenty advantages.
Fine. Online we are enjoying now. Online we are enjoying last 8-9 months. All the online, and we are all online only now. And your beautiful, wonderful presentation. On behalf of organizing committee, I thank you once again for taking.
Thank you, sir. Thank you. Thank you
very much.
Yes, sir.
I'm so honored. Thank you.
With the permission of chair, let me thank Dr. Jairaj all the way.
Please.
Coordinated with us. In fact, I was a little bit concerned that I was disturbing him in the odd hours, but still he could make his presentation.
Good. It's nice lecture.
Not at all, sir. Not at all.
Organizing committee, as a organizing secretary, we thank you very much, sir. Thank you.
Thank you, sir. I just want to thank all the organizers and Magesh very much, because he was just with me for last 1 week, and I'm so grateful to Magesh for reminding me and then keeping me online. Thank you so much.
Selvarajan, can you welcome the second speaker?
Thank you, sir.
Yes, sir.
You can unshare your screen.
Yes.
You remove that slides.
Yes.
Sir, can you
remove that
previous? You can remove that.
Right. Fine. Please welcome second speaker, Selvaraj.
Yes, I think without taking time, I request Dr. Lata to present the keynote address, please. Keynote talk.
Sir, with the permission of the chair, let me introduce the speaker because we got
please.
that.
Because you have not anything given to me, other than this one. And that's what I asked her, Selvaraj, to introduce something, 2-3 lines of K. Lata, and then ask her to speak.
Yes, sir.
Yeah.
So, if Dr. Selvaraj permit, let me
I have to permit you because you're not
next speaker.
Yeah,
I will
sorry,
introduce.
I am extremely sorry.
Hey, no problem, Nalatambi. Next
Yes, sir.
speaker I will introduce, no problem. I know him very well, but
Okay.
this speaker you introduce. Yeah.
Okay.
Yeah,
Thank you, sir. In fact, we are fortunate to have with us Dr. K. Lata, the Vice President of the R&D Division of the Stains Company in Coimbatore. And Madam has very long experience in the industry and farmers and the practical application. And she was the first one who was involved actively in the DNA fingerprinting at the CCMP at Hyderabad. And he is present head of the R&D division at the Stains. And Madam is highly involved in the PGPR program, biofertilizer, herbicides, etc. We all know that the tea stains company is one of the best company in promoting these agro products for the benefit of the farmers. And Madam is the head of the quality testing because we, the agriculture scientists, we know that unless the products is in good quality, it's very difficult. And Madam is the heading that division. In addition to that, she is the coordinator for all the R&D program in the Stains company, along with the ICR and the State Agricultural University. And Madam is promoting the new products and the other bio products to the benefit of the farmers, with having the lot of wonderful demonstration in the different agro field. So with these few words, we are fortunate to have the Madam. Madam, thank you for agreeing and our invitation despite your very, very busy schedule. And we are also especially to thank to Dr. Kumar, who was arranging this, Madam, to have with us. Thank you, Madam. Please.
Yeah.
Madam, unmute, please, unmute. Admin can unmute.
Madam, unmute and go for slideshow.
Yeah, I hope you can see.
Yeah. So you go for
Can you hear me?
slideshow.
Yes.
Yeah, it's on slideshow.
Yeah.
Yes, we are hearing you, madam. Continue.
Can you hear me? Good afternoon to everyone, and thanks for the introduction. It's nice to meet you all, especially the organizers who sort of convinced me that it could be a relevant platform, though I was hesitant. But even today, after 2 hours of listening to you all, I felt I might be an odd person out here. I think I'm the only person who's representing the industry. And the presentation today, I will be focusing on very precise objectives. One is we just, I think I'll go a little brief on the company. It is a 159-year-old company. For those people who are not down south, it is one of the large business house of South India, and having completed 59 years. And we have ventured into the biologicals more than 3 decades back. And and as like many other companies, the vision is always eco-friendly products. And most of these, whatever today we are, is I can say that we do credit to the discoveries made by the research institutes and the initiatives taken by the government, and also the approvals given by the regulatory bodies, that we are able to market around 42 products in various categories, from nutrient management to organic manures to micronutrients to disease management, pest management, water management, and biostimulant. Further details on the products sort of marketed by Stains, manufactured by Stains, you all can see on the website of T Stains and Company Limited. Yeah, having initiated all this, what the company or the industries majorly have done is, the translation part was a little difficult in the beginning, and we sort of customized most of those. And then today, as of today, we feel we are more confident in sort of producing quality products. And today my main objectives of the presentation is basically we are into this bioproducts and biologicals for agriculture. And what we found is agrobiologicals, though they are all well established, among the most around about 14 biologicals in the market, we find that 4 or 5 only have been established, and we found that there are some lacuna there, let it be in the terms of the technological gaps or the policy gaps. We just wanted to share some of this because we wanted to know we wanted the research scientists and the principal investigator to understand that the translation from their lab to land is very difficult, and we have to encounter a lot of challenges. And after encountering the challenges, the producer, the users, the environment, everyone might stand to gain a lot, but the industry still faces a lot of bottlenecks in spite of all this. So coming to this, we consider all the previously sort of discovered and established as generics. Now these, according to us, these are a good range of new generation bioproducts where the research institutes can gain much more, explore a little deeper, so that it will be benefiting the industry and also as well as the farmer. You all can also add if any other things are there which has been not listed here that could have promising marketing value as well as could turn out to be eco-friendly product and useful to the farmer. You all could add to this list. What we felt currently was these group of products, or rather components or bioagents and molecules that can be easily formulated as a product, can be worked in detail, at least touching upon, especially on the PGPF and PGPMs, and trying to see that how we could bring about research and innovation in regulating these biologicals also. Now, as of today, most of these biopesticides or biofertilizers have their respective regulatory bodies, but where do these stand? Whether they come under biopesticides or biofertilizers, or will they stand under? So unless we have clarity on this, even all the discoveries are made in the research institutes, we may not be able to commercialize it or see that it reaches the user. So just before you sort of, once you unravel the efficacy of anything, let it be a new molecule or it could be a microbial or a botanical, we would like to stress upon to work on these basic inputs before the time we can go to the next step of the technology. But one is correlated efficacy data, where you have a data in vitro correlating well with the in vitro studies in greenhouse. Then validation of the claimed activity. Most of the time, reproducibility, it lacks reproducibility. So this is one thing which we are often facing with the research institutes. Then the basic production requirements, so that the prices for production should not be very exorbitant, because that will again have a consequence on the selling price. The other one is categorize it. We need to categorize into which regulatory guideline we can bring the product into. So these are some basic things before we go to the next level of the research. Otherwise, we'll find that most of them, it will be ending up with publication and with of no use for either to the industry or to the agriculturists. Now, I think the research institutes and the most of the what we call private and public, both R&Ds, whenever they go for a classical approach. We also request them to look at an alternate approach, because what we observed was whenever there is isolation from a new source or an unassociated source, those interactions are much more effective, because sometimes the co-evolved interactions are less disruptive. This is one point which you could think when we are going for looking at isolating a new bioagent, let it be, it could be a botanical or it could be a microbial. Then screening of agents, we need much more robust screening methods, so that we get 80 to 70 to 80% results when we go into the field. So when we are working on, and the landscape for molecular science has increased so much that it can be easily worked out what could be the major extensive research on the mechanisms of regulating the biocontrol process in plants. If it is studied, then we will know what will be its how it will perform in the field also. Then opt for isolates or botanicals or any sort of microbial extracts or new microbes when they have multiple mode of action. So what happens is when they are endowed with multiple mode of actions, we will find that the efficacy of that on a particular pathogen or as a nutrient, it could be a solubilizer, a simple solubilizer. So when it is endowed with all these traits, the effectiveness of that particular bioagent is more when we apply it to the plant. Then, and this science has developed so much that even when we go for registering the genetic stability and the durability, it is taken for granted that most of the biologicals have genetic stability and durability, but it's not for all. There are one or two isolated cases that destabilization also has taken place. So this is one more point to be pondered while we are going for doing intensive research. The other thing, what we would like to know more about when any isolate or bioagent has been discovered is what is its tolerance to as many as influencing factors. Then only we will be able to know that there is a ecological competence for that particular agent. Then other thing what I would like to also emphasize is after introduction of a biocontrol agent, it could be a biopesticide or a fungicide, whatever it is, it's after 6 months or 3 months, after a few 1 year, with the recent molecular analytical kits and all, will be able to retrieve those organisms and sort of confirm its stabilization. And if it has, in case, disturbed the innate native microflora or not. These are some things when we go for the international market, the patent behavior of the introduced microbial agent is being questioned. Then the other thing is due emphasis on the formulating agents, which enables the deployment on the target location. This is something most of both from the industry and from the research institute, that public-private partnership can help in sort of preparing a formulation that can effectively deliver the bioagent to the target. Then the other thing which is totally undermined is the compatibility with the current package. Most of the time what happens is the whole process enables the AI to the desired level of concentration or activity. Finally, in the process, very little work has been done. What would be the right package, how it will work along with the current package. For example, if it can the bioagent can be mixed with along with the chemical fertilizers, or from the scientific level it is totally discouraged. But from the practical point of view of application in the land, this synergism has to be worked out and made clearly to the user that yes, it is not synergistic at all, or yes, it is synergetic, only that it is temporary and it recovers on the degradation of the chemical moiety so that it can be successfully incorporated into the ICM. This is one point most of us sort of do not pay much attention, and there is a lot of scope of work in this area. Then the other point where I would like to dwell upon is the formulation technology. Finally, after the discovery of its efficacy, efficiency and all, if the product is not stable and it is not able to the formulating agents are not able to enhance the pathogenicity or retain the anti-pathogenicity, I'm sorry, I have to correct it, the virulence of the bioagent, then the whole the process of the time and the money cost that are gone to develop that product is absolutely, it is of no significance at all. Then the other major thing is whatever additives we have adding while formulating the product, it has to comply with the organic certification. Otherwise, even for whatever way you try to convince them that it is a biological, so it is entitled, it is eligible for organic certification, will not hold good with any of the regulatory agencies. The last and the most important one is the container content compatibility, where we have to subject it to the right container. The container not in the flask or what you call lab level good highly moisture barrier containers, but the container that goes commercially, that sort of either the PET bottles or the foil packs or something, the product has to be tested in that particular container for its successful implantation or transfer into the or deployment into the field, either in the soil or to the as a foliar spray. Then the biggest constraint that industry is working upon and also sort of sponsoring projects with most of the R&D institutes, especially down south, we have one of the premier institute who works in relation to with this. It's National Institute of it's abbreviated as NIST. So we are working on those fermentation technology, the problems associated, the technical problems associated with fermentation technology with some of the research institutes, sponsoring those programs so that we find that we get very what you call standardize those methods so that we maximizes the biomass and also the cell count of the microbials. The other one is mode of action and its efficacy under varied agroclimatic conditions. These validations sometimes is debatable, but not at this forum, but we would like to take it on another session someday. And what are the application practices? How can we, after giving the product, is it consumer friendly or not, or it added on the cost of the farmer for applying and getting the net result? This is, and while developing any particular technology, the infrastructure, especially for agriculture use, that matters a lot, because finally the production infrastructure is very huge and the cost involved is high. It will become a big burden for the farmer also to buy such products. Then the most biggest burdensome on the industry is to develop the toxicity profile. So in case this is already be done by the inventor and the developer, this sort of gives us at least on the acute toxicity part and the residual toxicity part, if this could be sort of done at the research institute itself, the remaining, the subacute and the chronic part can be taken, because the industry is assured that there's the toxicity data is to a great extent safe. So it is worthwhile going for the next steps of toxicity data development. And I wish to share one or two slides on the biologicals which we are marketing for the past 25 years. What we got it from the field. These are some of the observations from the field. Efficacy is low, especially when the disease development. If the conditions are favorable for disease development, then the efficacy is low. It is slow, that is, I think everyone knows, and it is a universal truth. Then controls pests and pathogens, but variability varies every year, wise and location. The same location, last year they got good results, in spite of the quality of the product has been equally good both the previous year and this year. Then there is location-wise and year-wise, and they are hesitant to use multiple microbial-based products to control pests. They, in fact, prefer that they would like to have one particular product for all the pests. Let it be of different insect orders. Let it be from coleopteren, or it could be hemipteran, or any other they prefer to have. That is from the farmer's point of view. Those are some of the things we have frequently being encountered, this sort of feedback. And from the field managers level, what we find, the product development managers of the company, usually what they bring about is a little more details, application time. It created a problem on the effectiveness. Biologicals are target specific, so we cannot recommend for everything. Compatibility with chemicals is low. So this is where we would like request that any type of product, if its compatibility is good and it is only any sort of changes, variations are only temporary, it is better we include. This is only to help them. though we practically are not interested in mixing biologicals and chemicals, then it is very effective only during the initial stages of infestation. And final analysis are from the R&D of our companies. This could be the probable reason that we are facing these challenges from the field is ecological competence of the strain. Yeah, definitely some of the strains has performed very well. I think it is well known that Trichoderma, Pseudomonas fluorescens, Bacillus subtilis, they form, and Bacillomyces lacinius. All these four stand out among all the biologicals. And about the other strains, we feel it could be the ecological competence or the traits of the bioagent, the stability of the product. It could be the sensitivity of the particular pathogens. Different pathotypes could cause inconsistency in the efficacy of the product, or the durability, or at what conditions does the mode of action switch, so that the opportunity becomes an opportunity for the pathogens to dominate, and the mode of application. These are some of the things which we felt could be the probable reasons. And definitely the technical problems, this has been addressed by us, and we have made rapid strides in these areas, especially in the downstream, and we are trying to see that the quality issues is brought down to below. This is one of our what we call quality management systems mandate, is that we have to bring the quality issues less than 5%. And the futurist product which we could propose to the most experienced principal investigators and the team of JRFs, SRFs is try to bring about high sensitivity products, cost effective at low volume and dosage. These are some things which is more acceptable and also practical today. Then what about the microbiome and PGPM based products? Yes, we are ready to take the technology. Are you all ready to give us the right guidelines for registration? We will also commercialize. Then when there is a technology transfer, we need thorough know-how of various aspects of the bioagents. Unless those aspects are known to us, it becomes difficult to commercialize. And validation, we request that once a particular technology or has been developed or invented.
Madam,
yeah,
can
this
you
is the
wind
last
up?
slide.
Oh.
Yeah, we are the last slide. And we would, in this process, we can improve the efficacy of the bioagent. This is and with this, I would like to conclude. These are some of the certifications required for marketing, and it is very mandatory. And to be competitive in the market, these certifications are needed. And for these certifications, the technical data developed is much more needed. Otherwise, for you all to see your discovery taking shape will be difficult. I thank you, and thanks for all the opportunity, Dr. Kumar and Dr. Nalathambi and ADGPP. Some of the points I would like to also convey to him, what will be the status of the new molecules and bioagents because he's part of the big task force from the registration point of view. Thank you.
Thank you, madam. Thank you very much for your nice presentation. And industry representation is very important in the developing science in plant pathology. Thank you on behalf of the South Zone and on behalf of the organizers. Thank you once again. Thank you very much.
Okay.
And the next speaker, I think next speaker is ready. Professor M.K. Nayak. Professor M.K. Nayak, Honorable Vice Chancellor of Agriculture University, Shimoga. Of course, he is a good friend of mine. And he is going to speak on the bio-entrepreneurship in post-COVID-19 agriculture. M.K. Nayak is having a vast experience in the area of plant pathology from last 22 decades, 2.5 decades, and he is a well-known plant pathologist. And M.K. Nayak has published more than 190, 200 papers in the area of plant pathology, and especially he's worked on the biological control and developed some bioactive molecules as a drug, as biopesticides. And he published more than 58 book chapters and 11 books. and he produced 10 PhD per students, and also is the fellow of 6 societies in the country, and he is a very prestigious C.V. Subramanian Outstanding Teacher Award. I think M.K. Naik is a well-known scientist for all of us. I need not introduce much. He is having a long biodata, and I request the M.K. Naik to deliver lecture, and I requesting him to maintain the time. Time is 1 o'clock to wind up, and we have a 15 minutes. And I think you have to wind up 15 or 16 minutes, 1 or 2 minutes extra. Professor Naik, dais is yours.
Thank you, Professor Niranjan, the chairman of the session, Dr. Shalvarajan, the co-chair, Dr. Nallathambi, the president of the IPS-South Zone, Dr. Uma Maheshwari, councillor, all the distinguished speakers of the morning, Dr. A.K. Singh, Dr. Chakravarti, Dr. Sharmaji, and all my esteemed plant pathologists of the country, as well as the particularly South Zone chapter. I have decided to make a presentation on bioentrepreneurship in post-COVID agriculture, probably slightly away from the actual plant pathological research, but passing through the current era of COVID, and the country is also, government of India is encouraging a lot of startups and incubation facility encouragement for those things. I thought, let me take up some of these bioentrepreneurship available for youngsters, so that microbial origin products, including plant pathogens and other microbial agents, mostly of them could be very useful in future. So I'm sure Professor Niranjan will give me a few minutes extra, hoping that I will start my first slide.
Only 2 to 3 minutes.
Not more than 20 minutes, okay?
Okay, fine.
Yeah. Yeah, if you look at the hunger map of India with 135 crore population, I think we have about 23 crores people with insufficient food. That means almost about 17% malnutrition, acute malnutrition. Almost the double of them with chronic malnutrition. So this is the figure for India. I'm not going about world. And if you look at the COVID era, that's what we are passing through now. During this period, we have about, in India, today's data, 9,43,000 cases. Okay, to confirm the cases I'm talking about, 94 lakhs and 31,000, with deaths reported about 1.37 lakh. This is on the one hand. Of course, as I told you, if you look at the Indian map, some of these states, Madhya Pradesh, Maharashtra, Karnataka, Tamil Nadu, are under moderately high hunger, prevalence of insufficient food. And some of these green belt, slightly green, showing moderately low hunger, 10 to 20%. So that is the situation of currently when we are passing through the COVID. If you look at the major pandemics from the 20th century, the almost 100 years back, 1918 to 19, we had 50 million deaths. That was because of H1N1. Then Asian flu, almost 1.1 million. Then HIV/AIDS, today's record is about 32 million. COVID-19, just 1 million, above 1 million. So this is the data. I think if you compare, almost 100 years later, we had this epidemic of COVID-19, which has its own impact, particularly on Indian agriculture. So March 24th, the day we started the lockdown, we faced it was actually at the peak harvest and with no procurement. So generally, people were moving from, there was almost a reverse migration from urban to rural area. So there was a big disruption in the supply chain. Essentially, that was the one thing which made us miserable sometimes. And but as you say, most of the times it suffered was perishable fruits, and lockdown induced debt and cash flow was also a problem witnessed. The quick data says the lockdown has impacted more on the small farmers, smallholders. That means the food insecurity was directly proportional to the size of the farm. Smaller the farm, he was more vulnerable. Larger the farm, he was better. So 10% of the farmers could not harvest, 60% harvested but lost the yield, 25% they preferred to store over selling, 12% of the farmers are still trying to sell their crops. So what I would say, empty shelves can be frightening, but empty fields and barns would be devastating. That's why we could not stop agriculture. We can stop anything else, but not agriculture. That's why Jawaharlal Nehru said everything can wait, but not agriculture. We went for lockdown without much preparation, and suddenly we have to open it. That was because of this reason. And incidentally, you can think that at that moment, the COVID-19, in spite of that, India could feed about 80 crore people from March 24th to July 31st, feeding almost through about 24 million tons. And in spite of that, that included, below poverty line, above poverty line, everybody, all sections of the people. But the most important point is, even after that, about 80 million ton was still in our godown. What I would like to say, in spite of the fact that we were passing through all other service sectors were in the negative growth, but that trimester, the agriculture showed positive growth. That is number one. Secondly, and even before the Rabi harvest of wheat came, that added another 80 million tons, taking our godown tally to about 130 to 140 million tons. That indicates that the country had a resilient power as far as agriculture is concerned. And the Kharif season and the next Rabi season, the crop covered was more than 7% of last year. That is the strength of the agriculture that helped. And in spite of such a COVID era, and maybe in future also, such of those exigencies agriculture can meet, because that is the strength it has given. So the reforms that have been suggested, farming should be becoming more competitive, definitely, because we saw integrated market is the only necessity. In our own, this one, we saw about 95,000 tons of, pineapple was grown, and every day 25 to 30 loads were actually sent to what you call the northern parts like Rajasthan, Delhi, where it was used for canning. But we could not send it because of the lockdown, and we lost about 90,000 tons. What I mean to say, so that farm gate infrastructure and having a space for integrated markets wherever it is possible to sell, that can give a good strength. Then only you can achieve better prices, and that can strengthen agri-processing. I think if you want to go for economic development, you have to have good factors, operating production of products, good market, and then we can always go for foreign export. So this is the impact. What could be the sequence on the crop protection? I think the sequence is that supply and availability of plant protection products, availability of biological controls, what Madam Lata mentioned now, even the spray operators, health regulations, and availability of pest controls. The controllers were the ones which were affected. So the global protection gradually looks beyond this, not just COVID, even it goes beyond the initiation and completion of COVID-19. These are some of the initiatives in plant protection post-COVID era. So there is a need for what we felt is digital technologies, because in our own university, through social media, we could sell about 972 tons of vegetables and fruits. So I think it is time to have some e-clinics and digital technologies and crop-specific advisory through the e-resources. Some of these have already been used. For example, Karnataka is using Plantix, and of course, ESAP is the one originated from Raichur. And otherwise also, I think using Skype, Facebook, YouTube, LinkedIn, all those have helped as a social media to develop apps in plant protection. So this is what we see the changes in the last 70 years in agriculture. So change has been there because we have been able to go through deficiency to sufficiency, food security to nutrition security to food safety, food import to export, green revolution to gene revolution, and subsistence farming to commercial farming, and from chemical farming to eco-friendly or microbial farming. That's what we have been listening in the last two sessions. Now it has become a problem of plenty. In spite of having all these, first in the production of milk, second in the production of horticulture crops in the world, and probably egg production also gone up by 27 times. We have not come out of, because now the problem of plenty has arisen, but the global Indian hunger or malnutrition is another. That's why we cannot build a developed India on the shoulders of a stunted and wasted children. So that is why, and Indian agriculture, as we pass through, although there is a sufficiency, but there is always a criticism that it has not generated the employment opportunity. It is not a job-led agriculture. That's why this particular bioeconomy, what we call entrepreneurship, is a new direction that has been brought through this Atmanirbhar Yojana. So that can help for answer for many of the current form of job-led agriculture it can bring in. For example, that's why I have chosen bioeconomy. That could be a solution. These are the natural resources, whether it is a soil or land or water or energy, which can always yield good crops as a primary product. From that primary product, we need to go for secondary product for inducing productivity gains of a smallholder, for reducing the food cost, and also generating the growth and diversifying the income, and also an entrepreneurial opportunities, not only for creating job, even for addition of value. So these are some of the possibilities connected to microbial origin and plant pathological. So those are bioagents and biofertilizers and bioremediates, secondary metabolites, enzymes and proteins, biotechnological and diagnostical biosecurity. For example, we have heard morning session on UG99, effectively managed. Like that, mapping, pest risk analysis, diagnosis, accurate detection, all these come under biosecurity. Remote sensing also is useful, and some of the clinical managers, climate managers, looking at the climate variations, agro-based industries, and biosafety and mycotoxin. It's mapping, it's low-cost detection, and its management using good agricultural practice. We definitely need biosafety and pesticide residue, because that is the one we are presently facing. How to get a good, what Professor Chakravarti was speaking about, MRL. We have to have a food free from the residues. So I think one of the best is microbial origin, which has got biotransformation, production of alcohol, bread, useful metabolites like plant growth hormones, biomass production, single cell protein like yeast, microproteins, enzyme activity, tempeh food, biological control. All these are microbial origin. Each one has got its own potential for entrepreneurship. These are some of the range of products, valuable biological products like antibiotics, starting from penicillin discovered by Alexander Fleming, and then organic solvents like butanol and ethanol, beverages, food, cheese, and flavoring agents like monosodium glutamate, organic acids, then amino acids like L-lysine, then yeast, which is a single cell protein, biofertilizers, bioagents, enzymes, amylase, etc. If you look at the spirulina, which has got the highest potential, India is one country, Asian country, and African suffering from protein calorie malnutrition. This is going to be one of the best source of protein, can give a boost to the immune system, improve our digestion also, and control our appetite, and can maintain the good cardiovascular liver health. And there are as many as 10 top companies I have listed, which are demanding, fresh spirulina, like DIC Corporation, Tinajan, Pondicherry, spirulina, several EID Perry, etc. Similarly, microbes of bioenergy. I think at a time when we are searching for energy security, to decrease the greenhouse gases and to reduce the global warming, some of these Trichoderma, Aspergillus, Saccharomyces, Gymnomonas have been used. There are examples. Mass scaling is definitely needed. Even some of the genetically modified Escherichia coli has been used for ethanol production from Gymnomonas mobilis. So I think biofuel using microbial origin of products have been identified. They are to be in the place now. Bioremediation, for example, biodegradation and bioprocessing, and like Deinococcus, radiodurans, Pseudomonas, and alkali genes, these have been identified to degrade the radioactive waste, oil spillage, alkane, etc. So these are also going to be the scope. Micros for energy, they can really convert chemical energy into electrical energy. And this electricity generation does take place in the microbial fuel cell. All that happens in the anaerobic condition by releasing carbon dioxide and so also protons and electrons. So one of the best example is geobacter. Similarly, probiotics, which has emerged as a good food, particularly yogurts, kefir, sauerkraut, tempeh food, kombucha. These are some of the very, even pickles. They are going to be a very health benefit, and they can be consumed for probiotics. Even now, instead of using some of these conventional bioagents, probiotics are emerging as biocontrol agents, even for some of the bacterial, fungal diseases or degradation of heavy materials, and sort of also plant growth promoting activity. Mushrooms, I don't have to tell about for plant pathologists. There are about 10,000 mushroom fungi, 100 are cultivated. Ranges of mushrooms are available. I think they have got their own nutritional value, high protein content, less carbohydrate, even zero cholesterol food, antibiotic compound is there. They are anti-tumorous, and in fact, they are being used in some of the surgeries as a good medicine. So some of the valuable product that we have sold in our own university is pickles, okay, then soups, chutney, mushrooms, mushroom dried, chips, etc. Vast scope is there. We in Karnataka has got about 4 lakh hectares of areca. But if you look at the areca husk, which will be a nuisance because that pollutes, or else during rainy season it blocks the drainage. So one of the microbial consortia developed at our university using a consortia of Trichoderma, Aspergillus, and Pleurotus. Otherwise, this takes almost 2 years to degrade, and it contains heavy lignin. That's why it's very difficult. But this microbial consortia can bring it to a powder form within less than 5 months, and has got high CN ratio, very good nitrogen, phosphorus compared to FYM, which is sometimes sold at 10 rupees kg. I think it has a vast scope. When you look at the waste, we can convert the waste into wealth. This is how we have developed and demonstrated. Many farmers are by utilizing, and it could be developed into agri-entrepreneurs. And of course, this is a honey. I'm just giving an outside example. Nazir developed range of ginger honey, garlic honey, cinnamon honey. Today he's competing with many of the Dabur and Patanjali, and he launched his own company as Farm Honey. Of course, it is in agriculture. Of course, biosecurity, lot of scope is there, both in biosecurity as well as biosafety. When it comes to our chili crops, almost because of pesticide as well as aflatoxin contamination, we are not able to export it. So that is why large scope is there for mapping of aflatoxin prone area, the detection, low cost detection, and there is a good scope for developing entrepreneurship here also. PGPM as a green approach in the current era has taken up and has to be scaled up, and it's a question of $1 billion. Infinite possibilities are there because they are a natural choice, they are antimicrobial, induce systemic resistance, growth promotion, several other multiple traits. And these are some of the list of PGPMs. Trichoderma, of course, conventional one, then Candida, then Empiromyces quisqualis, that is Dr. Lata mentioned in her, as a vice president of the Stains company. And many of these, there are a large number. Then bacteria, Pseudomonas, Bacillus, Pasteurella, penetrans have got scope to scale up. And because these are some of the products, secondary metabolites identified in our own laboratory, a dozen of antibiotics like 2,4-DAPG, phenazine, phycocanin, pyronitrin, pyroluterin, HCN compound, very good antimicrobial compound, siderophores. All these perhaps the young researchers can take all these antibiotics. Some of them are very useful for growth promotion, biological control, even for human diseases. Many cures have been obtained. That's why I think they are going to be useful. And trichoderma, of course, very wider adaptability. There are cell wall degrading enzymes, chitinase, proteinases. They have a pharmaceutical value, paper industry value, textile value. They are now compatible with pesticide. People are working on it. And with the genome sequencing, they have really come up with so much of secondary metabolites, as many as 200 bioactive molecules, volatile antibiotics, a range of peptobiols, sterols, phenols. Some of them we have studied in our own laboratory, but definitely elicitor of disease resistance. This has given a new vista, having evolved as a mycoparasite with 200 genes identified. Strainal improvement is possible. It has also revealed the genetic secrets of biocontrol, and many candidate genes have emerged. And it has become now a vast reservoir of cryptic secondary metabolites. Kite genes like these have been used against pathogens, against thermotolerance, against salt, against cadmium. I think there is a vast scope. We cannot simply think as a bioagent. Similarly, we have to look at the
time is up.
Yeah. I'm concluding. Climate resilient bioagents, extreme temperature range, even they should be, we can't say that they are panacea. They have to be compatible with pesticides, herbicides in an agroecosystem. Their formulation, mass scaling, and then of course IPM is going to be our agenda now, because we have only covered through bioagents and IPM. All these products are available, but hardly in India it is covered in 4% of area. So that means if you look at the biological farming, microbial origin farming, or non-chemical farming, we need to, really mass scale all these products, whether it's a neem seed or trichoderma or trap crop or HNV virus, everything to the extent of at least 10% if you make it. That gives scope for several entrepreneurs. I just give one example, being a pathologist, one example of how we conducted IPM from 5 acres up to 500 acres in a green revolution area, with comparison of IPM and non-IPM for thrips, the difference for mites, for aphids, for cercospora in chili, for powdery mildew 22 and it's 28, dieback, and also fusarium wilt and coccineres. These are the natural agents, predatory spiders, chrysopora also being encouraged in IPM. And ultimate economic analysis, we could see that we could only in the spray where the farmer is spraying about 22 sprays, we brought it down to 8 with the 5 bioagents and spray, and then harvested about 3.55 tons with almost a net return of nearly 2 lakhs. This was conducted continuously for 7 years with a bio-BC ratio of 1:5.82. So this is what this is the last slide to say that sustainable development goal, as Professor Chakravarti pointed out, that the International Year of Plant Protection, that's what we have been, plant health management, where at least 3 agenda: no poverty, zero hunger, then good health, and sustainable consumption and production comes directly under agriculture as well as plant pathology. If you really want to meet these goals, way forward is to have agriculture as an engine of job-led growth, not merely becoming science, technology, engineering, and medicine. We have to add agriculture and fit it here. Then only it becomes a self-employed and Atmanirbhar Bharat for sustainable development, achieving the goals of sustainable development, for social protection of hunger. And the end of the lockdown will not end the problem. This is not just the end of the impact, it is the start of the impact. On the contrary, the need of the hour is to maximize the possibilities of agriculture, which has demonstrated its utility and resilience in everything. Unlock the economic potential of our country. Everything can wait, but not agriculture. Thank you, Professor. Thank you for bearing with me. Thank you for your patient listening. Thank you very much. No, you are not audible.
Fascinating presentation. So presentation is very effective and informative. Normally we don't want to ask question in the keynote lecture. So there is no question. So we decided not to ask all the three speakers.
Okay.
So first I would like to thank Professor Nallathambi for his presidential remark, and he has given presidential remark. Shalurajan, you want to tell something?
Yeah, I can. If you give
please,
you
please,
can,
please.
1 minute, yeah.
Please.
So it's the keynote addresses, including the South Zone presidential address on the wheat rust pathogen and other aspects, and it was very wonderful session what we had now, and the talk from Dr. Jayaraman from the West Indies, talking about the seaweed extract or algae. That was a very wonderful talk, because very rarely we listen to such a talk in IPS, because this particular keynote addresses all the addresses. They never talked about the fungicides. I am very happy that we give eco-friendly management opportunity, and it's a wonderful talk from Jairaj and Dr. Lata, as well as our Honorable Vice Chancellor Dr. Nayak. And Dr. Nayak talk, he never talked about even any negative aspect of the because we always talk about the disease, plant disease, this is causing that much loss, this much loss. We never, but this particular keynote addresses of all, we talked about the positives, and all the speakers, they talked about the positives, what we can come out and how we can resolve. And again, how even the COVID problem is there, the agriculture is in the positive side of development. And yes, our VC said that we have got a very huge quantity of rice in our gudons. That's very interesting. And again, and very, very positive side of the plant pathology we talked about. And I am very, on behalf of the IPS South Zone, I am thankful to all the keynote speakers for giving a wonderful talk on bioagents and the positive side of eco-friendly management of diseases. That's all from my side, sir. Please go ahead. Chairman, sir.
No problem. You are thanked by everybody. On behalf of the organizing committee and on behalf of all of us, we thank all the three speakers of keynote lectures and one presidential address. And thanks again for the organizing committee to giving me the opportunity to work as a chairman for the keynote addresses. And I think now science is developing and growing. Even online presentations, it is helping all over the country. Because of this COVID-19, MK Nayak was explained how the science is moving. You cannot stop science. Whatever may be, the COVID is also a science. COVID, the virus is so easily it is spreading, and it is a man-made virus, and we cannot control. We have controlled. We are not able to control viruses, even plant virus. Like that, human virus also, we are not able to control that. It will go on its own, and slowly now it is coming down. Incidence has come down, but up to that, another 2-3 months, we will wait for the complete elimination of a virus. Then we will move. This online presentation has helped us. We are interacted very well. Once again, I thank all the participants for patient listening. Still, I have 88 participants I am seeing in computer. 35 have been left. Okay, no problem. 88 is the high number for participants. And Nallathambi is a well-organized meeting online. And I am thanked for giving me the opportunity. Once again, I asked excuse for the organizers. I have to attend another meeting. I have to go to the university. And all the best for all of you, and Happy New Year for everybody. Thank you very much.
Thank you, sir. Thank you, Chairman.
Thank you, Dr.